right? And we can also do some graphics. We'll also see the activity questions of week 6 because this is where we all are struggling, right? So we'll do like that. You can unmute and speak. Okay. Yeah, so activity questions. All right. So maybe we can take up directly activity questions and then keep discussing the concepts. So, but you need to talk. Then only I'll get to know like if you understood or not, right? So before going to activity questions, I want you to tell me some concepts on domain and range, and then we can actually take up questions. So I'll just quickly do it in like if I think you will be fine with the graphics, but let me just check that and then we can start within 15 minutes after we can start with the activity. Okay? So maybe we can just start with, so like let's do it some kind of, okay? Because this will be helpful for solving those activity questions. So that's why I'm giving emphasis to this. So how will the graph look like for this function? Good morning, Satyam. So please unmute and speak. It's being very one-sided now.
Yes, sir. Morning, sir.
It will be linear. Hello, can you able to hear me?
I don't know, you are not audible, Ramlal, and I think that you have unmute yourself.
Sir, am I audible?
I think only sir can't hear us.
Could you put it in a chat window? I guess it's not audible.
I think, sir,
Hello, can you able to hear me now?
Yeah, sir.
Yeah.
Graded assignment is
Okay, everyone is audible. Am I audible? I think yes.
Yeah,
I should also
we
be audible.
can hear you.
Guys are not audible to me. How is this?
Hello. Hello. Can you able to hear me?
Maybe
Yeah,
I myself will join again, sir. You are audible to us, but somehow you can't hear us. But I guess okay. So maybe I'll disconnect myself and then join here.
My call Rosma. Tolom. Oh yeah, okay. Cool. You are the so fine. Sangeeta, what happening?
Okay, am I audible now? Can you speak?
Yes, sir.
Yes, sir. Yes, sir.
Can you hear us now?
Try to speak, anybody?
Hello.
So
Am
can
I
you
audible?
hear us? Hello.
Yeah, Vicky said your screen is not visible.
Okay, so I don't know for what reason you guys are not audible to me, but I think we can start. You can actually put it in the chat window and then I can take responses from there.
Hello, can you able to hear now?
I can hear you, Ramlal, but I think sir is unable to hear us. Must be some.
Oh,
glitch.
okay. Participant can hear, but not sir.
Yes, something like
Oh
that.
my God. Yeah, it happened previously. That's the reason I disconnected and joined. But it's okay.
And there's some issue with speaker.
Okay.
So just give me a minute. I'll just ask host to make me co-host again. This is so bad. Yeah, I guess so. So let me see. Let him make me co-host again, then we can actually do something. Seven minutes, it's gone. Hello.
Hello, yes. The part we are participants. We can hear whoever speak
Okay, so
when we are
let's
waiting
not
for.
waste any more time now, and we can just simply start. Okay, so you can put your this thing in the chat window. I just checked with my settings here, like it's fine here. I don't know what is the issue, but let's see. Linear graph. Okay, sir, can you check your speaker? So yeah, that's what I was checking right now. I did not get it. I get from here, right? So it's not working out. But anyways, let's just start now. Okay. So this is not going to be linear anymore. So how is this? Of course, you know that you can say this is going to be x. But when we say this, we go with assumption that x is greater than. Whenever we say this, we say that x is greater than or equal to 0. So that is something we go with an assumption. Just give me a minute again. I'm sorry, like I'm getting some technical issues. Okay, so whenever we say this, we actually mean that this is x is greater than 0, and then we write something like that. X is greater than or equal to 0 here in this case. Yeah, so this is the very essential thing that we should pay attention to. Okay, so whenever we write like this, we actually mean this, right? When x is greater than, it's not a subset, it appears as if like that, but x is greater than 0, then you can come to this part, that is root over of x square is x. Okay. So maybe some issue with the audio setting, mod x. Okay, so now this is something, yes, it's going to be graph like that. So you would see this. So how does this graph look like? So how, whenever you do a graphing of a composition function, so it's wrong to say it's a composition function, but actually one way we can say is this is a quadratic and then it's under root of that quadratic polynomial, right? So how is that then? So you have to draw the two components and respect the definitions for each, right? So first of all, you know that I'll do the graphing for this one, that is x square. So how does the graph look like for x square? It's going to be something like this, right? So you would see this is 0, and this is how the graph look like for x square. Now, how will the graph, this is for x square, and we know that since this is a polynomial, it is defined on all r, right? Then what about root over of this? Root over of this is, since it starts with 0, so that's not a problem. You can actually take all the values of x. So even here, you will see that the domain for this entire function is again r, right? So but how is this happening and how will the graph look like? So you see that since these are the output values, whatever you get on this line, those are the output values for this under root functions, right? So it's under root of this values. Okay, so now since you know that if this is, let's say, 10, or let's say this is 100, so you know that under root of 100 is what? Under root of 100 is 10. So that means if I have to draw the graph for this, how will the graph look like? It's going to be something like this, wherein for this value, actually I should write here. No, let it be
One
dash.
kind request, can you guys go on mute, especially
So
Tayama,
for
because
10, it's going to be root of 100, and this is something it's going to be here, right? Similarly, you will see the graph for this on the other side, it goes like this, right? So you see that the graph for this under root of x square is going to be something like this. Now comes the next part.
again I repeat, can you guys
Now,
go on
if I
mute,
have to tell
especially
you that,
Tayama?
do the graph for this one, that is x square minus 1, let's say. Okay, so how will the graph look like? Again, the same way, what we will do, we will first draw the graph for this, and then we'll do the graph for root x. Okay, so what about x square minus 1? So if I have to factorize that, then how can I write that? It's going to be x plus 1, and it's going to be x minus 1, right? So we know that the graph for this would be -1 to 1, And since it's an upward parabola, so it's going to be something like this, right? So we draw this. This is the graph for this one. Now you see it says under root of this. That means, and you know that root functions are defined only for positive values greater than or equal to 0. That means I cannot take these values. I have to omit these values, right? In this between, like I have to omit these values. I cannot take these values because these are negative values, right? So once you substitute here negative value, it becomes complex, and that is something we are not considering, right? So what we can do here is, so you see from this part, after this it is being positive. So you know that as this is increasing, even this will increase, and it goes something like this, right? So the
Can you
graph
please
for
mute
root
all?
over of
There
x
is a lot
square
of
is going to be
disturbance.
this one, right? So what is the domain for this function? So the domain for this function, that is f of x, is going to be from what? Minus infinity to minus 1, where minus 1 is included, right? Union 1 to infinity, right? So you see this is something we get now, right? And how did we get it? By paying attention to every, like we are paying attention to every definitions of those functions. Over here it was polynomial, so polynomial is defined on R. So you see that the graph turns out to be a smooth curve, and it's going from minus infinity to plus infinity, right? So you see for polynomial that
Hello.
is okay, but the moment you take
Hello.
mod of that, right? When you take the mod of that, so but mod functions, it's always defined on what? This value should be greater than or equals to what? That means x square minus 1 should be greater than or equals to 0. So where all it is greater than or equal to 0, it's only these reasons, right? But not these reasons, isn't it? So that is why we omitted this part, and we get the graph like this.
At least
Clear? So the
participants,
graph
can you
for
mute
this
all? There is some
thing is
lot
this
of
red
noise
thing.
is coming.
Okay.
I think Vicky is unable to listen. Something is going on.
Okay. So this is some intro about this. Also, you would be facing problem. I'll come to logarithmic part also, so no worries. But I just want to give you an idea like how will do the graph or functions when something like this is given, right? So let's see this. So now let's go with another thing, and then we'll build up our concepts of domain, and we'll take up the activity questions. So now you see what is the graph for, let's say, x plus 5, suppose. Now these are x plus, you can try speaking, but I think it's not audible. Noise disturbance, mute everyone mic. Oh, I see. So what I'll do is I'll mute you all. So I'll mute you all actually, because I will not know when you are speaking. Some technical issue from my end, so I'll mute you all. So I'll do that. Just give me a minute. Okay, I guess now you cannot unmute yourself. Okay, so I think now you cannot unmute yourself. So now let's start and focus here. Okay, so I'll take up all activities, and you can ask your questions here in the activities in the chat window. It's kind of difficult, and it's like very kind of monotonous. You're not speaking and I'm just speaking, so it's okay. So now let's see this. So now we understood that how does the graph look like for the some functions which is not a logarithmic functions. Now we'll do one more graph which is not of logarithm. So how do we actually do the graph for these kind of functions? Okay, right? So why am I teaching is I'm giving you an alternative way of doing things. You can also do these things when the question asks whether this is one-to-one function or not, all these kind of things you can do even mathematically, but I'm just trying to give you an idea how you can do with graphings as well, right? So that is something, let's understand here. So whenever you get some graphs like this, right, so it becomes very difficult because these are not the normal functions which we dealt with, right? It's something not exponential, it's something not, polynomial, it's something not logarithmic, right? And it's something not quadratic and linear or anything like that, right? So how do we do the graph for these kind of functions, right? So here, for these kind of things, we have to, like we have to break this. You have to think at the extreme conditions. So what you do is, whenever you have these kind of functions, right? So what you should do is, you have to keep something in your mind while drawing the graph for this. Okay, again, the graphing is not really important for this part, but of course it is important once you can visualize something. So this is something you can consider as one of your way of doing it, right? So now, how do you do the graphing for this? So maybe I can just tell you some steps. Step one, okay, look for function. Let's say this is our f of x, which is something like this, where all it is not defined, right? You first look for the domain, right? So you first look for the domain of f of x. So this will give you an idea where the function, this will tell you where all the function is not defined. This will give us where all the functions are not defined. Not defined, or it is going to infinity or plus infinity or something, right? So that is something we can keep in our mind as if now. So this is where all it is not defined, right? So this is going to be plus infinity or minus infinity. Let's go to step two. So step two says, what happened at, what happens when, like when, when x goes to plus infinity and x goes to minus infinity, what happens, right? Then this is, and over here, wherever this function is not defined, you actually tend your limit to that point, and then you check whether what happens to the functions. That means, let's say, I'm talking about step one itself. Let's say this function f of x is not defined at some point a, then you would, what you do is, you actually tend your limit x tends to a, to that part, and then you see the graph for that, like how does that behaves. For example, I'll just show you here. And another thing, like step three, you can say that finding intercepts. Hello.
Hello, can you hear us?
Okay, I guess 1 minute. Just give me a minute.
Yes, no.
So yes, you guys are speaking, but I think I'm not audible to you again. The same issues is as this.
No, you're audible. No, sir is not audible. That is the problem.
No, we are not audible to sir.
So remaining all participants are audible, but sir is not audible. So the only way to interact with him is via chat.
Oh, sir made me a host.
Yeah, I think it's the same issue again. I'm not audible to you guys.
So friends, I request everyone to go on mute because
One
it's a
more thing
one-way
is,
communication.
I will just connect with my phone and then I will try to speak from my phone and write on the screen. Maybe I can do that. So just give me another 1 minute and then we can start. I'm sorry that, like half an hour is already gone. So just give me a minute.
Whoever is not speaking, please mute yourself. Now there is a lot of disturbances coming. We are only 24 people. Can't we mute ourselves if you are not speaking?
No, there is no need to, even though we speak, there is no use because sir is not able to hear. So better we will go on mute.
Yeah, true. There is a lot of disturbance. Someone is doing some other works and kept it on mute.
Hello, am I audible?
Yes, sir. Yes.
Oh, thank God. I connected to my phone now. So yes,
Okay.
I will be speaking through my phone, but writing on the screen.
Okay, that's
so
better now. Yeah.
yeah. So let's do like this now. Okay. Yes. So I think now we can start our session, normal session. You can see my screen, right?
Yes, sir. Yes. Yes.
Okay. Okay. So I just quickly want to know what you really want. One is like activity questions discussion, right? Of week 6.
Yes. Yes.
What else?
Yes, sir.
Any
Sir,
concept?
So
graded
the domain.
assignments can we discuss because the deadline has passed?
Okay. So what I'll do is I'll mute you all and just one person speak. Okay.
Sir, can we discuss graded assignment questions?
Can you listen, Vicky? Again.
You can speak. You can speak. I guess hello. Am I audible to all of you?
You are.
Yes, sir.
Okay. So could you tell me which all concept you want me to discuss?
A composite function domain with number line you explained last time for logarithmic function. The same, can you repeat?
Okay. So maybe I'll take up that
Number
kind of.
line.
Yes, yes.
Composite function with number line.
And in
So,
addition to
Sir,
that,
this question completed. This one graph of
okay.
sir, could you also complete this question that you had started?
The answer logarithmic function is general.
Excuse me, sir. Hello. Am I audible?
Yeah.
Yes, yes, speak.
Because sir was not responding, I thought I was inaudible. Um, Sir was explaining this question fx equals to x plus 5 divided by x minus 3, and then at the third step he said we will going graph the function by considering a constant a where function f is not defined. uh, can someone explain how this is going, because it's going out of my
Yeah, I'd really like to know
Okay.
the answer to this also.
Okay. So,
Yeah.
so
At
I'm
x is
audible.
equal to 3, function is not defined.
Am I audible?
Yes,
yes,
yes.
sir, you
You
are
are
audible.
audible now, yeah.
Okay, okay. So let me speak now because I did not speak for half an hour. So let me speak now. Okay. So now let's do this. So most of you are wondering, okay, this is doubt clearing session, and then you started with your, teaching concepts and then going. Your doubts will be clear. Don't worry about this. But there are so many whose concepts are not even cleared. So we'll go in the order. First, we'll do some concepts. Then we'll go to the doubt clearing session, right? So we'll go in this order. So now you see this. What I was first, we'll complete this. Then on general, not much details, but yeah, somewhat I'll give you some idea about this. But again, this will be more of question oriented type only, like general discussions on log. Okay. So not in depth because we don't have time. So coming to this part, see, we know the graphings of, we can do the graph for linear function, quadratic, right? We can even do for exponential, logarithm, right? So all these things we can do, even polynomial, right? So these are like very standard functions wherein we can do the graph, right? But the moment we get something like this, we go blank, like, no, now what to do, right? So there are some steps, and there is no standard way for doing this, unlike the other graphings, right? So here what you have to do is you have to look, see, I'm telling you here there are some steps, right? So first, what I was telling you, step one, find the domain of this function. So domain tells you like for which all region this function is not defined, right? And then we look at the behavior of this functions where this function is not defined. And then what do we do in step two? We look at these values, like what happens when x goes to infinity and x goes to minus infinity. And I was telling you here in step one, like when this happens, like when we told that the domain of function where this function is not defined, so what we do is actually for those particular region or for those particular point, we actually see how does the graph behaves. Like does it goes to plus infinity, negative infinity, or some other or is there some kind of breakage or something like that, right? So that is something we deal in step one itself. Now in step three, what we do is we find the intercepts, right? So find the intercepts. So it can be both, right? Y intercepts and x intercepts, right? So this is what we do. See, this is essential. I'm not wasting your time because I'll bring you here when I'm discussing activity questions. That is why I'm explaining you all this. So pay attention with me, because each activity question one itself I can explain you in half an hour. But if the concepts are clear, I can take you in another 15 minutes, and I can just get it done. So what now? See, now we got to step three, and other thing is, like, if you want to see at some points what is happening, you can take some random points and check. So that is, we can leave that. So come to this part, let's see what is for this, right? So you see what happens. What is the first step? The domain, right? So what do we see in the domain? So domain says that r, it can be r but except 3, right? It is r but except 3, right? So our step one says this: the domain is r, the domain is r except 3. So now
So,
what is it? Yes.
so but in 3, the only case when it can't be 3 is in the denominator, no? In the numerator, it can be 3.
Sorry, your voice was not clear.
Hello?
Yes, yes.
Sir, in the denominator only, it can't be 3. But in the numerator, it can be.
Right, I'll tell you why. See, first of all, look at this function. How do you identify what is the domain for these kind of functions? So please mute yourself. Yes. So now, how do you identify this? Okay. So look at this top part. Look at the numerator. Is this a continuous function? X plus 5. Yes, it is continuous. It is continuous everywhere, right? And look at this part. You will say this is continuous everywhere, right? So both are fine. This is continuous everywhere. This is also continuous everywhere. But look at this function as a whole, right? This function as a whole,
you have to make sure that this denominator is not 0, right? So what did you do? You first check whether the numerator, uh, what is the domain for this numerator and domain for this denominator, right? So you found that the domain for this is all R and the domain for this is all R. Now you will be checking what is the domain for this whole function, right? So for doing that, since you see this is a fraction, right? So you have to make sure that this is not equal to 0, right? So how do you do that? So you take just this part and you make sure that x minus 3 should not be equals to 0. And when is that not equals to 0? When x is not equals to 3, right? So this function on overall, it is defined on R but not at 3, right? This is how we got to know the domain for this function. I hope this is okay.
Yes, sir.
Okay. So now this is the domain for our function f of x. Now maybe I can write this as domain of f is all are these things. Now since this is not defined for 3, so what happens at 3? It goes to what? Infinity, right? Something like that. What happens when step 2, let's go to step 2, what does it says? What happens when x goes to infinity? In other words, what are we doing here is, look at this function. So x plus 5 divided by x plus 3, right? So how do you do this? So when x tends to infinity means what do you mean by that? You are
So
actually
here
finding
the
the limit.
value of x
Yeah,
tends to
X,
yeah.
3.
X takes very large value.
So what do we do here is we actually find limit when x goes to plus infinity. So how do we do that? So we do what? So 1 plus 5 by x and 1 plus 3 by x and limit x tends to infinity. See, initially what we used to do was like, this is what we do, no? When x goes to infinity, what happens to this function? What happens? This will become 0. This will become 0, right? And you will be left with what? 1, right? Right? Are you with me?
Yes, sir.
Yes,
Yes,
yes.
sir.
So when this function goes to infinity, this is actually going to 1. Okay. So that means if I keep increasing this x, this goes to 1, right? If I keep increasing x towards the positive direction, it goes to 1, right? Now what happens further? What else we can do with this? Now when we say that when x goes to 3, what happens to this function? It becomes not defined, but not defined means it can be infinity, right? So it can be either this side or this side, right? So that is something we have to check. Okay. So now what happens? Now you see when you approach 3, what happens to this function, right? Let's say you took some values, let's say uh, maybe we can say 2.5 or something, right? So when you take 2.5, just a minute, I'll just erase this part. So I hope this is clear. When x goes to plus infinity, you got this, but also when x goes to minus infinity, you see you get this, you again get this value when x goes to minus infinity also, right? No doubt,
Yes.
isn't it?
Yes,
Yes.
sir.
So for positive
Yes.
infinity and negative infinity, it is giving me the same output, that is 1, right? But what is happening in between is something we don't know. That is something we'll check. Okay. So now this is something we have as if now. Now let's go with our step 3, find the intercepts. So what happens when x is 0?
Sir, can I interrupt just once?
Hmm.
You're saying for plus infinity also it will tend to 1 and also
Yes.
for minus infinity?
Minus infinity will tend to 1. Yes. So we got this expression, right? So we got this 5 by x and here we got 1 minus 3 by x. So when x is positive infinity or negative infinity, it will go to 1, right? In both ways, it will go
Okay.
to 1, right? So this is for infinity case. That is why I have written. So this is 1, but I don't know what is happening here in this part. I don't know what is happening over this part. So that is something we'll have to determine. So for doing this, we will first find the intercepts for this, right? So what do you do? X plus 5 and x minus 3. I'm just rewriting it here. What is f of 0? F of 0 is minus 5 by 3.
Minus 5 by 3.
Right? So this is
Yes,
going to
sir.
be minus 5 by 3. So
1.6.
so that is something minus 5 by 3 means somewhere here, right? Somewhere here, minus 5 by 3, isn't it? Okay. And what happens when do you think this is going to be
f when do you think f of x is 0? So that means you can write this x plus 5 divided by x minus 3 is equals to 0, or when this happens, when you throw this to that side, you will get x. When x is minus 5, you get this to be 0. So where is minus 5? Somewhere here, or let's say somewhere here, right? So minus 5 is somewhere here, right? So this is what happening. So now we got some part over here. So we can say this bending must be happening something like this, right? Can we make this conclusion?
Yes.
Right?
Yes.
Yes,
Yes.
sir.
That is something we can do. Now let's understand what happens at 3, right? So now this is something we have to exploit. The graph can go like this or like this, but I'm very sure this will go like this, isn't it? Look at the curve. Now let's look at 3, what happens. Now when you approach 3,
Sir, f of 0 is minus 5 by 3. If you substitute 0, it will be 5 by 3. Oh, okay. Sorry.
okay, no problem. So now let's go with this 3 thing. What happens? How does the curve changes as you approach this, right? So let's consider 3 somewhere here, isn't it? So now let's see if this 3 is here. So what happens when you go to very near value for this? Let's say some values, maybe we can give it as, maybe we can give this as, okay, let's go with what happens at x equals to 4, that is fine. But when you go for x equals to, let's say, maybe we can take some values like 2.5. So maybe 2.5 is somewhere here. So maybe we can, okay. So at 2.5, what happens? You will get some negative value, right? Which is traced here. At 2.5, you get some negative value, which might be somewhere here on this curve, right? Clear? What happens when you give 3.1? What happens when you give 3.1?
Positive.
You get
Positive.
3.1. So 3.1 means this is going to be 8.1 divided by 3.1 means this is going to be 3.1 minus 3. This is going to be 8.1 minus zero point 0.1, which is a big number, 81, right? So when you simplify, you get 81. That means this is going to be very large. So that means after 3, to some point, it's going to be very large, right? So this is what the nature we can expect. Something we can think of.
Yes.
Are you with me? Right? So at 3, this is something, it's happening, right? Because if this is 3, if I take some values lesser than this, that is 2.5, and if you take 3.1, so at 2.5 you are getting some negative value. That means it is somewhere here. This is if this is your 2.5, and if you take 3.1, you get a very large value, that is 81. That means that is going to be somewhere here. That means at 3, this curve is definitely going to infinity on the positive side, and over here, when you are approaching from left hand side to this point, it is definitely going to the negative side. So this is one conclusion we can make, and this is some rough diagram you can make. Of
Seems
course,
sir.
it took a long time.
Oh.
Yes,
Sir, how did you get the asymptote in the line parallel to the x-axis?
that's what I explained you. Like you go in the step by step manner. First, you find the domain, right? It's the same step. In the process, we understood this. First of all, we understood like what happens at infinity in both
Oh
directions.
yeah, yeah.
That is something we understood. Then we found this intercept. Well, how did we get this? F of 0. And then when does this f of x become 0? That means we found out x intercept and then we found out y intercept. This is just to tell us how does this curve goes, like where the bending is happening, right? We initially made sure that this is what happening, right? And now you see this from here, we got to know that the bending was happening like this. Now we will have to see at that region where the domain was not defined, right? So this was the region at 3, the domain was not defined. So now when you are approaching from this direction and this direction, what happens to the curve, right? So when you are approaching from this direction to the 3, now the nearby value for 3 we took it as 2.5, and another near value we took it as 3.1, or whatever you can take. That is no restrictions on you. But just for simplicity, I took this value. When I took 2.5, I'm getting negative value. That means okay, this curve is extending like this. And at 3.1, I'm getting some positive values, that it's going to be very large positive value. So it's going to be something like this. So I can make an conclusion that yes, this curve at 3, when you are coming from right side, might be going to positive directions of infinity, right? Positive direction. But when you are coming from left hand side, from this direction, this is going towards negative directions. This is how we got this graph. Now see, you need practice for doing these kind of questions. Similarly, you can practice for 1 by x, you can practice for x minus 1 divided by x plus 1, or like whatever these kind of functions, right? You can practice in a similar manner. You will get it, don't worry. If you do for 2-3 questions, you have the confidence, and then you can draw the graph, right? And I'm pretty sure you can do the graph for linear, right? You can do for quadratic, polynomial, exponential, logarithm. And when you have something like this, you will have to do some kind of work here. What do? What happens when x tends to extreme condition, that is infinity and positive infinity, and what happens at the not defined region? Which direction does the curve move, right? You take the nearby values, like very nearby values, and then you check. That's it. You will get the values. Okay, clear? So you can do the graph for this also now. This is
Sir,
what I was doing.
1 by x looks very difficult because even finding the intercepts will be difficult because at x is equal to 0, it's not defined, and then if you equate it to 0 again, it will be tough.
Okay, so we can just do it here. We can just do it here. So now you see this. What happens when x goes to positive infinity? 0. It's going to be here. So maybe I can take different color. So maybe
So
yes,
it will
I can take this.
also have the same kind of graph. Like for 3, it is
Yes,
not defined,
yes.
and it will have the curve like the same one, right?
Right. So this is going to be like this. Over here for negative, when you take a positive infinity, it's going to be flat at 0. And when you take negative infinity, it is again going to be flat like this.
So, I'm not understanding how do you tell that when positive infinity it's going to be 0.
You're not understanding this.
When you told that
So
when
what I
positive.
mean is, what do you mean by 1 by infinity?
Oh
1 by
yeah,
infinity is 0.
Oh, yeah.
What
Now
do
I
you mean by
understood.
1 by positive infinity? 0. What do you mean by 1 by negative infinity? Again 0. Right?
Yeah.
So when you get something like this, what you can do is you can mute. So once you speak, please mute yourself, because let's help each other, right? Not disturb each other. So what you do here is 1 by x. So you got to know this is what happening at the extreme condition, but not sure of this. When you give it 0, it turns to infinity. It's become not defined. You cannot give 0, right? Because this is a not defined region. When 0 is not defined region, then what you should do? You should take nearby values. So what are the nearby values? Check 0.1.
Excuse me, sir.
0 minus 1. Just let me complete this, then I'll take up. So these are the two things which you can take nearby values, right? Right?
Yes.
Yes.
So now what happens? Now when you take positive 0.1, that is somewhere here. So what happens to this? This is going to be 1 by 0.1, which is nothing but 10. That means this is very large value. This is something like this. What happens when you give this minus? So this is of course same thing, but in the negative side. Like this it goes. I hope this is clear now.
Yes, sir.
Yes,
Are
sir.
you okay? You
Yes,
can do
yes.
now. So now you can do any kind of graph if it is given like this, x plus 5, x minus 5. Just the same thing. Look at the extreme conditions and look at where all that function is not defined. Okay. So just practice some, you will get it. Okay. So you can do these graphing. So now let's come to the log part, and then we can go with our activity questions. Okay. Yes, somebody asked me doubt and I did not take it that time. Yes, please ask.
No, sir. Excuse me. I was talking when we are talking about x goes 1 by x, and we said infinity. We were taking values of y, and we said at y will go to infinity at what point? We were talking about x going to
No.
infinity.
X goes to infinity, then what happens to y?
Okay, sir.
Like that we were doing. Okay. So
Sure.
now let's do this. Now we understood something, some
Excuse me.
graphings like this. Yes, yes.
I have something to add. Like the last function we discussed, x plus 5 by x minus 3. Yeah, we can. It is somewhat difficult to visualize this. If we were to simplify this, it would be easier to visualize the graph. Like you can write this as 1 plus 8 by x minus 3.
1 plus
8 by x minus 3.
8 by?
Yes, x minus 3.
X minus 3. Okay.
So this is of the form 1 by x, so, similar to 1 by x, right? Some constant plus 1 by x.
But again, for that you will have to know what is graph for 1 by x, right?
Yeah, exactly. You have to know some basic graphs, then you can visualize. Otherwise, it will be difficult. But this
over here, what I'm telling you is you can do the graph for 1 by x itself. You don't have to memorize the graph for 1 by x.
Yeah. What I meant to say
Of course,
was
this is also doable.
Yeah, fractions are difficult to visualize. So if you do it this way, it is somewhat better.
Yes. You can do it in this way also.
Okay.
Whichever suits you best, you can do that. Okay, that is perfectly fine. So all right. So now let's get to the logarithm part. Okay. So now what do we do in logarithm thing? So maybe again. So just to tell you how does this happens. I have discussed this long before. So maybe I can tell you again what happens to this. You know that log x square is something like this, right? And if you are with me, and I have also told you many times, how does the graph look like for log of x square? It goes something like this. Maybe should be symmetric. So it goes something like this, right? All of you know this, right? How to do the graph for this one? No doubt on this?
Yes, sir.
Okay.
I'm still confused. Log x square equals to 2 log x.
Yeah,
But the
but I just
graphs are
explained it
entirely
very
different.
simple. No. It's actually different. Why? It's just because of this. When you say this is equal to 2 log x,
Yes.
when you say this, it is equals to 2 log x. When this is equal to 2 log x, I'm sorry, my battery also got discharged. There's so many problems for this pen. So, okay, so 2 log x. So when do you say this? When x is greater than 0. This is the condition. So now, this is always the condition. When you say log x square and when you're writing in this form, you go with this assumption that x is greater than 0. Now look at the graph part of this, okay? So now let's look at the graph part. The graph for both are different, of course, right? How is that different? Log x square graph is this, but log 2x graph is just this. Just this. Hope I'm clear.
Yes.
Yes,
Right?
sir.
Right. So how did we go to that part? We went with an assumption that x is greater than 0. It will exactly coincide on this, you see. When you take these graphs, it will exactly coincide on this. But what is the assumption? X is greater than 0 and then only you do this. You see, most of the time when we write formulas, right? So we say that x is greater than 0. Maybe we don't pay attention to that at that point of time. But the actual thing is this. When you look at the graph, you understand its importance. I hope this is okay.
Yes.
Okay here? No doubt? Okay.
No
Now we will
doubt.
build concepts here. Okay, no doubt. Now we'll build our concepts here and then we'll go to activity. I'll do a small graphing again here and then we can go to our activity questions. Okay. So now let's discuss this. If you still have doubts, so just to bring everyone on the same page, log x minus 1, x plus 2, x minus 3. How does the graph look like? Right? So just let's draw this, okay? So whenever we draw the graph, I told you first draw the graph for what is given inside, right? So now this is 1, this is minus 2, and this is 3, right? So I'm doing the graph for this part. So how will the graph look like? What is the degree of this polynomial? This is polynomial. The inside one is polynomial.
Three.
An odd degree, right? And what is the leading coefficient? Positive or negative?
Positive.
Positive. So now we know that if it is this, then definitely my curve is going to be it's going to look like this, right? I don't know what is happening inside, but you're sure this is what happening, right? Now see, this is the multiplicity of these each roots are what? 1.
1.
So it will just cross at the roots, isn't it? It will go like this. Now you see this, what are we doing here is we are taking log of this output values. Now what are the output values? Output values are these values, right? These values, the y values of this, right? Right? Am I clear?
Yes.
Yes, sir.
Okay, so if we are clear with this, so could you tell me what is the output values over here? Is it negative or positive?
Negative.
Negative. So I cannot have log of negative. I cannot have log of negative. So I can omit this
No.
part. I cannot have these values.
Yes.
Right? Okay. Now look at this part, and this part. These are my intercepts. So this is where it is becoming 0, right? When it becomes 0, what happens to log? What happens to your log?
It's undefined.
It's negative infinity. right? So at this point, when it is 0, that means when this becomes 0, it becomes this thing, right? It becomes undefined, or it becomes negative infinity. Now let's look at the other thing. Now
So
what
can
is
you
happening?
explain again? I didn't get after when
Okay.
log is negative.
Okay. So now I am clear till here that I cannot take these values. Is it? You
Yes,
understood
sir.
till here? Okay.
Yes, sir.
So now let's go to the other part. This looks very linear, but it's not very linear. Okay. So just pardon that. So now you see this, I cannot have negative values, right? Now these are the points which I have plotted for this one, this red color thing, right? So now what is happening is, for which values it is becoming 0. So you see at 1, at -2, at 1, and at 3, this becomes 0. Now what is log 0? So now if you remember log x graph, how was the log x graph? Like this. And this was 1. This was 1, yes. And at log 0, what was happening? This was going to infinity, right? And on the negative side. Am I clear on this?
Yes, sir.
Yes, sir.
So this was going to infinity and on the negative side. So that means when this becomes 0 at 3, this will go to infinity on negative side. Because this is not negative of log x, no? This is positive log x, right? So this is also positive log x. That's why it's going to the negative side of the infinity, right? So this is what happening at 3. And even at 1, this will go like this. And even at -2, it will go like this. But I'm not sure what is happening here inside, right? And what is happening in these regions. Isn't it? Am I clear on this aspect?
Yes.
So now let's
Yes,
go to
sir.
the other part. Now let's go to the other part. Now what happens? As this increases, then log of that increasing value is also increasing value, no? Am I clear?
Yes, sir.
Log of 10 and log of 10 and log of 100, which is bigger? Of course, this one, right? So as this is increasing, so even my log function will increase. Clear?
Yes, sir.
As this is increasing, even this will increase, but it will not increase the manner in which this is increasing. This will increase very slowly, the log of this value, right? Am I clear?
Yes, sir.
Any doubt here?
Yes.
No doubt? Okay. Now I cannot do anything for this region. So this is a breakage. I cannot do anything for this region because you see, when I give the negative values, it become undefined. It is something not defined. There is no definition. I mean, it's violating the definition of logarithm, right? So I cannot do anything here inside this. Now look at this part. As this is increasing, so even this should increase. And when this is decreasing, so even this should decrease and it should come like this. Clear?
Yes, sir.
Yes.
Okay. What about these regions? Now this is going like this, no? This curve. This is again giving me the negative outputs, isn't it?
Yes.
This is again giving me the negative outputs. Then log of again negative is not defined, so I cannot have any graph at these regions. So in other words, the graph for this log of this function is this. I mean this entire thing. Okay, clear? So
Yes, sir.
clear?
Yes.
Okay.
Yes, sir.
Clear.
Okay. Okay. So if this is done, then let's move ahead. Or
And this
let's
is called discontinuous function. I mean, not
yes,
continuous.
this is not continuous because you see this. Okay, could you tell me what is the domain for this function? This log x, log of this entire thing. Could you tell me what is the domain of this function?
R minus 1, 3.
No. You cannot say like that.
-2,
Minus
comma
2.
one-
Minus
minus
infinity to minus
-2,
two.
comma
Minus
1.
X, 3, infinity.
Wait,
Minus 2, comma minus 1.
minus
Sorry,
2
1.
comma
Minus 2,
minus.
comma 1.
Minus
1,
1,
plus
comma
1.
3.
1.
Are they
Union
included?
To infinity.
No.
Are they included?
3 to
No.
infinity.
Union 3,
3
comma infinity.
3,
So
infinity.
this is the domain of this log function.
Yes.
Okay, clear?
Okay.
I hope this is clear now. So we got
Yes.
to know what is the domain of this log functions. Okay.
Can
Now,
we define the range for this function?
can you tell me what is the range for this function?
That we need to find out now the peak
Range
point of
will be
log,
Minus
how much
infinity
it
to
is.
plus infinity.
yeah, minus infinity.
find the minimum value for this log, maximum value.
Sir, we are not able to hear you.
Is it okay? Understood?
A range.
A range.
Yes.
Range.
Range part is clear to you now?
No. You were not audible.
Okay, what do you mean by range? Just you
Range
speak.
is along y-axis.
Could you tell me what is the range?
0 to infinity?
No. Tell me the definition
Minus
for range.
infinity also is
Minus
The values that the function can take.
0 to minus infinity.
The output of the function.
Minus
Minus
real
A possible output.
Yes,
Possible output, right?
Real numbers, right? Yes.
But 0 is not included, no, sir?
Yeah,
0 is included, no?
here it is included.
Over here it is included. Even here you will find zeros.
Okay. In this curve it is
Output values do not get
okay. 0 is included. Correct.
Yes. So it is set of all output values. Right? So now we understood what is domain and what is range of this function, right? Do not get confused. I always see you always get confused with the definition of range. Range is the set of output values. Though theoretically I will bring that PDF file and I'll say, yeah, range is set of all output values. Like, yeah, we know this. But the moment you give this practicality, like we give a question to you, then you'll be like, okay, what is range now? Right? So range is all set of that output values.
So this will
Actually,
be from minus infinity to infinity, all real it will be all real numbers from minus infinity to infinity.
Yes, minus infinity to infinity. This can also be written as R.
Actually, what's my doubt is, if we don't have the right side curve, if you have only this parabola type, then how to find the range?
Then you will find this peak.
Yeah, that's how to find that. That's my doubt actually.
Okay. If this is the case, then it will be a parabola. It will be some quadratic equation if you're getting this curve.
Then we can take the vertex.
Then find the vertex and get the value.
That will be the peak.
That will be the peak, yes.
Okay,
so I hope this is
sir,
okay.
I have one more doubt. Sir, in this function, the range and the codomain are the same. Is it not, sir?
Yes.
Sir, can you just elaborate on, how do we differentiate that codomain and range, sir?
Okay, I'll tell you that. So this is what we were getting the function, right? So see, when codomain is R, like if nothing is given, just think that as an R, okay? We say this is defined from this function, let's say this is F. This is defined from some D to R. And I'm saying this is my codomain. So codomain we tend to give you always. Codomain is set of possible all output values that this function can take, but it's not the same thing. So the range is always a subset of a codomain.
Okay.
Range is always a subset of codomain, right?
Okay.
So codomain is something, it will be given to you. We'll say that, okay, this function is, you take these values. Something over here we can say this is R, right? Then what do? You find range and then you check whether this range is a subset of your codomain. Okay. What will happen when range is a subset of your codomain?
Can you repeat, sir? What will happen?
It will.
So over here we saw that range is R.
Yeah.
And your codomain is also R. So which kind of which kind of function this is? Is this onto function?
Onto.
It is onto. It is onto function. What is this 1-1 function? Look at this graph. Is this 1-1 function?
Only on the right hand side?
No. You should not restrict yourself on R. You should see. So on its domain.
No.
It is. So it is onto, but it is not 1-1. Right?
Onto range equals to codomain, na? Is it similar like range? Range subset to codomain.
When range is equal to codomain.
Yeah, you said subset.
But it is 1-to-1 from 3 to infinity.
That is something we can always do. We can restrict domain and then we can understand that, right?
So this horizontal line, if you pass, it will cut in 3 places, the bottom one. So it is not 1, 1. I arrived at like that.
Okay.
You can take this x intercept. You can take this your horizontal line
X
to be your
intercept.
x-axis only.
Yeah. So we have 3. So
that also will do.
Sir,
Okay. So
for
now
the,
one more
for
thing.
the
One
so
more
for the
thing.
same graph,
Yes, sir.
this will be from -2 to 3. It will be increasing or decreasing, or what should we say?
-2 to 3.
Like the previous graph only.
Okay.
It has that discontinuous part also.
Yeah. So what you will say is from where to
This
where?
is increasing or decreasing from -2 to 3, if the question is asked.
From where to where? -2 to 3.
3. Yeah.
That kind of question should not be asked because we are talking about non-defined region, and I think we have given a typo question to you like that. So do not get confused. We will never give you like whether this is increasing in non-defined region, right?
Okay.
Okay.
Nothing can be
Sir,
said about it.
But
another
if
thing is
this
that the range is
graph
-infinity
is
to infinity, and how we can say it is onto? Could you explain that? -infinity to infinity.
See, when do you say onto? When range is equal to codomain. When do you say onto? When do you say this
Range
is
is
onto?
equal to codomain.
What is the range for this function? R.
-infinity to infinity.
Which is R. Right?
Yeah.
And over here I am telling the codomain is R. So you see, both are same.
Okay, it is given in question that codomain is R. So that only.
सर अगर ये discontinuous नहीं होता तो फिर क्या होता? It will be increasing.
अगर ये discontinuous नहीं होता then मतलब you mean to say but like this?
Yeah.
So this is increase. No, but again you will have to restrict. So you have doubt in increasing, decreasing. See, what happens is like first of all, whenever we talk about anything, like any properties of function, we will have to make sure that function is defined in that region, right? If it is not defined in that region, it's really doesn't make any sense. You ask whether it is increasing in that in that breakage part, like where the function is not defined. So first of all, we will never ask you a question like that. Okay, wherever it is defined, there we'll ask you whether this is increasing or decreasing. One thing. Secondly, how do you know whether this is increasing or decreasing, right? So that is something by looking at the graph you can say. From here till infinity, from this point to infinity, can you tell me this function is increasing or decreasing?
सर ये छोटा छोटा पार्ट बन जाता है लाइक आई थिंक ग्रेडेड असाइनमेंट में जो साइनसोइडल ग्राफ आपने दिया था उसमें जो रेंज दी थी उसमें इट वाज डिक्रीजिंग आल्सो इट वाज इंक्रीजिंग आल्सो बट वो समझ नहीं आया कि वो क्या होगा सो आई लेफ्ट दैट पार्ट आई डिडंट चूज एनीथिंग
I have a doubt in this. If after the lady finishes, I want to ask.
Increasing, decreasing function.
Yes.
Yeah.
It first increases and then decreases. This kind of thing.
Yeah. Then what we will call this?
Okay,
finally
so
increasing or finally decreasing?
It's see for example this graph first increases and then decreases. You cannot say this is a graph of increasing function or it is a graph of decreasing function.
So if we take the roots like अगर ये 1 से 2 तक इसके roots हैं तो हम ये कह सकते हैं कि 1 to 1.5 it was increasing, then 1.5 to 2 it was decreasing, but as a whole we cannot say anything, right? Okay, because I think you asked a question, monotonicity increasing or decreasing between some interval, but I couldn't understand कि उसमें होगा क्या, so मैंने choose ही नहीं किया कुछ भी उसमें.
Sir, here if you talk about the definition of the function, I have one more doubt, sir.
Yeah.
Sir, can I
I'll mute.
Sir, I mean, in one of the week 7 activity questions, something was
can we discuss
like,
bounded and unbounded?
Well-defined function, sir. Well-defined function.
I think we lost him again.
Okay.
We will not discuss about week 7 today, so just keep that aside.
Sir,
okay, sir. No,
Can we discuss here bounded and bounded graph? Like we are confused here.
You're still confused with bounded and bounded. That is again 7 content. Maybe we can discuss tomorrow, but not now. Let's just give importance to week 6.
Okay. Sir, I have increasing and decreasing.
So now you see that yes. What doubt you have in that?
Okay. How I do is, please correct me. You draw one graph, sir. Just draw one graph. Yeah. Now what I do is from left to right, I visualize. So please correct my procedure. If from left to right, if it is always increasing, then it is increasing. From left to right, if it is always decreasing, it is decreasing.
Exactly. Yes.
From left
You
to
never
right,
go this way. You never go in this way, but you always go this way.
This way.
Yes, you're perfectly right.
Okay. Okay.
Yeah. Okay. So now let's go to our activity question. So we have discussed some of the things, and we'll discuss this thing more when we are doing activities, right? So now let's go in the order and let's see what is the first question. So let me just take you there and tell me what doubt do you have there. Do you have any doubt in the first activity questions?
Yes, sir.
Question 4.
No, 6.1. This is exponential.
So which one? So
6.1.
let's go with.
This is 5.1.
Go to week 6.
6.1.
Week 5. Go to week 6.
Okay, yeah, right. So this is 5. Yes. Yeah. Yes. I was busy. Like I got engaged with some work there. So anyway, so let's go with week 6. So week 6 first. So yes, this is something we know how to do. First question can be done. Can be done, right?
Yes. 4.
Okay, I'll mute again. First question, any doubt?
You have to take log of.
Here, what you will have to do is, what is that they're asking? For which point the Cartesian? So this is point. It's not some interval. Remember this.
I'm confused with the point to what it is.
Yeah. I know. Like we would go wrong here. This is not an interval. This is a point series. It says for which point. So this is a point. This first value is x value. The second value is y value. All you have to do is just substitute here and get it. Okay. Clear?
Sir, no, sir. I mean, even
no,
question is not very clear, sir. So x is log 2y equal to log 3y. What does that mean?
Do we have to take 2x equal
the first question, 6.1
over x?
2
to the power x
the
equals
first
to
question of 6.1, right?
Yes.
Yes, sir. First one.
Sorry?
First one. Does it say that log 2y is equal to log 2y? I mean, what is the question here?
It says that, but for what value of, at what point? That is what you just need to validate it. That's all.
Be
Now,
valid means that means LHS is equal to RHS. That should be 0.
All you have to do in this.
If we put 0 and 1, then x is 0 and log 1 is 0.
Yes. What you will have to do is you substitute this value. For 0, just substitute 0. Yes, that is what you will do. You will just check whether this LHS is equals to RHS or not. So what you will do, you will take first pair, that is this pair, x is equals to log 2y, and then check your LHS is equals to RHS or not, right? And similarly, you can do here. Or what you can do is individually find the value. Just your x is 0, then check what is your second term value when y is 1. It is 0. Similarly, check your third term value. It's not a term, but yes, this last value, that is log 0.21. So what does that give you again?
Got it.
0. Yeah. So it's just that you have to substitute. See, first of all, what I would say is we are thinking a lot about this activity. It's not big thing. What we have to first understand is it's just an activity. We just saw the lecture and then we are coming here and then we sing. So here we are not expecting you a big calculation. It's just that we want you to know, like, if you can substitute and get the values. That's all. I hope this is okay.
Yes, sir. Log 1 to base anything is 0. Okay.
Okay. Now come to second part. You can do this?
Yes.
Easy?
Yes.
Yes, sir. Yes, sir. Yes, sir. Yes.
This is easy?
Yes.
You can do this third one?
We have a doubt at log x whole square. Will the graph be on the either side?
Log x the whole square. So third question, right? So we can discuss this then.
Yeah, log x. No, no. What I want to say is, will the graph comes similar to log x square?
No, no. Log x the whole square is not similar to this.
So
It will be
it will be
different.
doubled, like x square. It will be something.
I'll tell you how. So you see this. This is something log x. How do you have the graph for log x?
It will go from.
It will go like this, right?
Yes, yes.
And this is 1. What about log x square? The graph will go
Go on
something.
the both sides.
Okay, so I'll just draw some of the graphs and then you will be able to understand this. Now when I'll do this log, let's say log x square, so the graph will go something like this.
Yes.
So maybe this not exactly coincides there, but it might be still more sharper or something like this. Okay, so this is your log x square. Now let's take the other thing. Maybe we can take just a minute, log x the whole square, right? So now look at this, your red color thing. Okay, so it's whole square, it's all log, but it's still whole square, right? So how will the graph look like? It will be more sharper, right? So it is going to be more sharper like this. But what about these regions? This will get squared, right? So this will bounce back like this. Clear? Okay, maybe I can do it here again.
Sir,
So
using Desmos.
Desmos and all, then if I'll use Desmos, then how will you do in your
Use,
exam?
sir. No, don't use, sir. This method is
Desmos you can practice.
You can visualize.
I mean, you can do it afterwards. Like
Yeah.
if I'll use Desmos, then what is the whole point? How will you do it in your exams?
No.
So you see this log x the whole square. So first, before going there, just go with this. What is log mod x? Log mod x. This is the graph for log x, right? This is log x. You see, this is 1. What about this mod? When this mod thing comes in, so everything is positive, right? So when you give this negative values to this, but this
We
will go
have to
like this.
remove the
It will
region
go like this.
below.
So what happens?
Yeah.
It will shift like this.
Reflected on the x-axis.
It go like this, right? Now similarly, what about this?
Sir, I
Now-
didn't understand why it would go that
minus
way.
log x.
okay, I'll tell you.
Sorry, I
So
didn't
no
get
worries.
this.
So
Okay, no worries.
So a log x whole square will come as a parabola.
Not
Just like
parabola.
x
It will
square?
be similar to this. It will be similar to this. I'll come to this. So
Please
maybe
explain
I'll just
minus log x graph.
yes. Just give me a
Sir, I
minute.
didn't
Okay?
understand this mod log x.
Okay, just a minute. Just give me a minute. So first, let's go with this. Log x graph is something like this. We are convinced, right? Log x is this.
Yes.
Now let's go with modulus log x, right? So mod log x means what? It's just
Sir,
this.
one doubt, sir.
Always only positive values.
Yeah.
Yes.
So now you see this. Just let me complete this. Log x is what? Log x is when you say log x, this represents y value, right?
Yes.
This entire thing represents the y value,
F of x.
right?
Yes.
So this is y values, right? So now what happens when you give mod of this? So this will become like this. It just reverses on the other side.
All positive values. Okay.
It becomes all positive because what happens when this is, let's say it's when you get let's say log of something is equals to, let's say, minus 10, but the moment I give it mod, then what happens? It will become plus 10. So it will become here, right? So
So
it will
that
come out
portion is mirrored in the x-axis.
here. Yes. So now you see that this blue color thing, now this will become your mod x. Now this is your log mod x. I hope this is okay.
Yes.
Now come to this part. Log of x square. Now what is happening here? X is okay. Now this is fine. Now I'll just remove this mod part from here. And then we'll quickly go to our activity because we need to spend our more time there. And we are already late. Now time's up. But now let's go with this. So log x means we know the graph for log x is something going to be like this, right? Log x. Now look at this. This is x square, right? X square means whatever input values you are giving. Let's say over here, this part, if it was 2. So what would, if let's say log x was 2, then what is log x square? Let's say if log x is 2, Then what about log x the
4.
whole square?
It will increase. It will be little
It will
slower.
increase. It will increase, right? So it will be what? Then what will be the value for that? It will be
4.
more. It will be more steeper, right?
Yeah.
So maybe it will be like this.
It will increase rapidly.
Yeah. So maybe it will go like this. Now what about this part? If let's say log x is -2, suppose if it is -2, then what happened to this one?
It will
-2
still
is
be
somewhere
4.
here.
It shifts to the
It shifts to the other side, so it turns out to be like this.
right or left.
Here, it goes like this. Right? It goes like this. Am I clear?
Yes, sir.
Okay.
Yes,
So
sir.
now we
log
understood
x
log
minus 2 means it shifts to the right. No.
Log
X minus 2.
So again you can do that. So what happens log x minus 2? Do not think anything about this. Just think at what values it becomes 0.
2.
When x is equals to
2.
When x is equals to 2. So consider this as 2. So at 2 it becomes infinity. That means I will have this line here, this infinity line.
Yes,
And as x increases, this will go on like this. Simple, right? I don't know about this part. This we can find out. You can equate to 0 and then find out that value.
Yes.
Right? So that is something you can do. So I hope this is okay. Now you wanted to know what happened.
Graph up log mod x.
Log mod x?
Yes, sir.
Okay. Let's take that as well. So log mod x, right? So you see this, first of all, mod x, right? Log mod x. So how will this graph look like? So when you give positive values, let's say when x is positive. So what happens when x is positive? For all 0 values, it will go like this. And mod x is, you are giving all set of negative values, right? So maybe when x is 0, this goes to infinity, right? So this goes to infinity means this is something like this, and as x increases, this goes like this, considering this as 1. Now what happens when you give the negative values? When you give negative values, this turns out to be again like this. I hope this is okay.
So sir, it is
same as log x
square, but it is
Yes.
less steeper.
Less steeper, you can say. Yes. Okay, so what is happening is just take these values. You just take negative side. When you take -1, what happens? It will become still 0, so which is here. Right, so I hope this is okay. Now let's go to our activity questions. So in activity questions, we were discussing that we had doubt there, right? So maybe I'll just open this part. Are you able to do this question, question number 3?
So I got the values, the zeros, which is 10 to the power 3 and 10 to the power 5. But how do we know it's 0, 10 to the power 3 union? Because I thought it will be infinity. So I was not sure on that part.
Can you do this?
Okay.
So could you hear me?
We can take, I think I have taken this question somewhere. No, I haven't. Yes, you're audible.
So you had
Am I
solved
audible?
this question
Yeah,
last
I
time,
guess.
sir.
Okay, so you tell me where you had this doubt.
Used square value, solve it as a quadratic equation.
Now you got this.
And yeah, this one.
Up till here,
Minus
you
infinity to comma 10 union 10 to the power 5 comma infinity. So
that is
the
only the
answer is actually 0 to 10 to the power 3. So that is where I was confused.
answer is, just let me see.
In the options, it is from 0, not minus infinity.
Okay, let me check. Then let's check here. Maybe I would have done it wrong here. So let's see this. So first of all, we went with assumption saying that this is equals to y. Log 10x is equals to y, and then we made the substitution, and then we simplified this, and then we got our graphs wherein this was forming here. So what did we notice here is?
Sir, one thing we can do is y minus 3, y minus 5. It should be greater than 0. So when we will do that,
right, so this is what we'll do. So this and this has to be greater than 0. So how will the graph look like? Let's go with our standard way of doing with the graphs, right? So how will this look like? So this is going to be 3 and this is going to be 5. So the graph is going to be like this, right? So in other words, if I substitute these values, so this is basically if I take x, right? So this is going to be what? 10 to the power of 3, right? Okay, this is going to be 10 to the power of 3, right?
So we can do it like this now. Y is less than 3 and y is greater than 5. So
yes, you can do that way also. It's essentially the same thing.
uh,
So this is 10 to the power of 5, and you see the graph for this is going to be like this. So maybe it's going to be like this and then going to be like this, right? So this is the graph for this function, isn't it? Now could you tell me what is the domain for this? Minus infinity to 10 to the power of 3 union 10 to the power of 5 2. But you see in that thing, this is the actual domain, okay? But in the option what they have given, 0 to 10 to the power of 3, which is still the subset of this, right? Am I clear? Oh wait, it's 0 to 10. Yeah, that's right. So it's 0 to 10 to the power of 3. Am I audible? Am I audible? Yes, yes.
Yes,
Yes, sir.
Yes,
Yes, sir.
It's fine when where we draw the graph of 10 to power 5 going left to right, but on the point 10 to power 3, the graph was, it was going, I wasn't able to understand how
How did
we
this
draw the
happen?
curve. Yes, sir.
I will tell you how is that happening. But you understand this? I was telling her that since this
Yes,
is
sir,
given,
I
right?
got that. I got this.
No,
So
no, no.
I
But she
didn't.
didn't
I
understand.
still didn't,
Yes,
didn't
yes,
get that.
yes. I will tell you her. I'll tell her that. So you see this here. Consider this function. The domain of f is definitely from minus infinity to 10 to the power of 3. Okay. This is not 0 to 10 to the power of 3. But yes, this is well defined in this part. Definitely, this is well defined in this part. Why? Because you
Okay.
see, what did we get the domain? We got domain as minus infinity to 10 to the power
Minus
of 3
infinity.
and 10 to the power of 5 to infinity, and 0 is subset of this, isn't it? Minus
Okay.
infinity means what? It will go till 0 and then only it will go till this part, right?
Right. Right.
So this falls
Okay.
under this. That's
Okay.
why that is given as, right? But yeah, as if now we can
Sir, may
complete.
I speak?
Yes, yes, yes.
Sir, I thought that it is given from 0 to 10 to the power 3 because log x base 10 belongs to minus infinity to 3. So
Minus
when
infinity. Go ahead. Go ahead.
we are
Yes,
trying to
yes, yes,
decide
yes,
where
yes, yes.
x belongs to,
Yes,
so
yes, 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 yes. You are right. You are right.
yeah,
Thanks
yes,
for
sir.
bringing
This
that.
is the
Yes.
thing.
Very good. Very good. Very nice.
Uh,
I just missed that point. So over here, what I just considered was, so you see what I was doing here is what I did a mistake here. Thanks for pointing that. So you see that what I did was like I just took only the definition for this one. What I made sure is only this is greater than 0, right? And then we went to this part. This is what we did, right? We told that this has
yes.
to be greater than 0. This is what we are telling, that this has to be greater than 0. But again, there is a log function inside, right? And that also has to be greater than 0. I mean, whenever we are proceeding this it is log x to the base 10. So first I'll have to assume that x is greater than 0. Over here also I will assume that x is greater than 0, right? The domain for this individual log is this, isn't it? Then we will take this part and then we will say that this itself, that is log 10x the whole square minus 8 log 10x plus 15 has to be greater than 0, right? So from here, what do we get? Are you getting confused here?
No, sir.
No, right?
No, sir.
Okay.
no.
So over here also we'll say that this is greater than 0. From here we got that the domain for this is something coming out to be like this, right? And over here it says the domain has to be greater than 0. Then I'll have to take the intersection between them, right? So how do you take that intersection? So now from here we got this up to 10 to the power of 3. It is well defined. So 10 to the power of 3 is somewhere here. So maybe I can just write here. So 10 to the power of 3 2, and this is 10 to the power of, and this is 10 to the power of 5, right? So I got this region from the inside part what is given, right? So I get this part, isn't it? from this, but over here it says that x has to be greater than 0. Now x has to be greater than 0 means which are those regions? Greater than 0 means all these regions, right? Considering this was 0. Considering this is 0, then this is that. Now what is the intersection part? These things, right? So this is going to be from 0 to 10 to the power of 3, and 0 is not included, right? Union. And over here the intersection part is 10 to the power of 5, and 10 to the power of 5 was not included over there too, right? This was like this. So 10 to the power of 5 to infinity. This is how we get this. Nice. Is this okay? Is this okay?
Yes.
Yes, sir.
Okay. Okay, so now you asked that graph part, right?
Yes, sir.
Sir, may I ask one question? Sir, here, when you have written log 10x equals to 3, log 10x equals to 3 here. So here, sir, if you can just remove this equal sign and you can put that inequality here, log 10x less than 3.
That is also
That is also fine. And then we can do it like x is less than 10 to the power 3.
Okay. So
this is allowed,
yes,
sir?
yes, definitely allowed. It's just for simple calculation I have written like that.
Okay.
Okay.
Okay, sir.
Yeah. So I hope no doubt on this. I think some of you are very quiet. Do you have doubt? No doubt?
Maybe when we do it ourselves, maybe we get clear.
Yes. You can see this video that time and then you can make sense out of that. So yes,
It
I
will be
was
recorded
explaining
now,
you
sir?
this. Yes. It's been recorded. Okay, so now we got to know, but do solve this because this is very nice question. Right? You would have noticed this.
Yeah, sir.
Yeah. So now, okay, we are done with that. So yes, I was telling you that graph thing, right? So how did that graph happen? So we went with an assumption that x is equals to log 10x, right? And when sorry, y is equals to this, and we got y as what? We got y as equals to something like 3 and y as equals to 5 we got, right? Isn't it? After solving this, when we considered this in the form of quadratic equation, right? So we just converted this. Now what you just have to substitute there. So now what do you do when you do that substitution part? This will become 3. So log 10x is 3. So that means x is 10 to the power of 3. And y is similarly 10 to the power of 5. So when we were drawing the graph of that log function, over here this is x only, no? This is x axis, right? So we will have to take the x values. That is why we changed that. So we took it in the x form and then we wrote it that thing here in this form. Clear? Clear?
Okay.
Yeah.
Okay, so now this is done. Let's go to the other part. So maybe we can go with next activity thing. So this is okay. Now we can get it, and now we understood why it is from 0. It's not from infinity, right? So it's from 0. So just because that you will have to respect this domain as well, right? Like everything you have to consider. Like if there are so many functions, then you'll have to respect the domain for everything. And how do you respect that? You do so by taking what? By drawing it on the number line, right? And then you find the intersection region and then you get it. Clear? Question 4.
If possible, can you explain once the number line with number line domain?
I just explained a while ago. You can just see this video again, you will get it.
Okay, actually it's not clear. Okay.
Yeah, you can see this video again because I drew that number line and explained. If I'll explain again, I'm explaining the same thing. So question 4.
Should we have to take log
Yes,
by
I have a doubt. If we can discuss
below
question.
and then solve it?
Okay. So you see, I think I have solved this question before. So I have did it here, right? And we have also drawn this. So maybe we can just discuss it from here. So you see this when I was explaining you this. I think those who have doubt on this number line thing, it will get clear here. So pay attention now. So see, this is what the question is, that activity question, right? So f of x is given like this, and then we have to find the domain, right? Do we have to find the domain? Yes, we have to find
all the
domain
set of x
values, right? So let's do that. So now you see this, what we have to do is, see, initially what I did for the previous problem, I did not respect the domain for all the functions which was given, right? So over here we have to do this. Everywhere actually we have to do this, but I missed that point there. Over here, what we have to do here is look at this part. This thing, we know that this is a log function, log of something. Then of course log of something, then this whatever is given inside, it has to be greater than 0, because we know that from the definition of log says what? Log x, where x has to be greater than 0, right? Now if we are respecting this, that whatever is given inside, I will say that is greater than 0. Clear? No doubt till here?
Yes,
Yes,
yes.
sir.
Yeah, clear.
So first part is done. I'll have to make sure that this is greater than 0. Come to second part. Second part, again, what do we say this whenever we write a log function? Log of this a, right? So where a is greater than 0 and a is not equals to 1, right? So I have written both the things here, if you can notice, right?
Yes.
No doubt till here, right? So because how do we do this? We say that log, how do we say this? That log a should be greater than 0, but it should not be equals to 1.
Minus
Right?
1 is included, na? X belongs to minus infinity comma minus 1.
Okay, we'll come there. But did you understood this? Like, why are we writing these three conditions? How did we get these three conditions?
Yes, sir. Yes.
Sorry, first one is clear.
Yes.
First one is clear. Second one?
Yes. Yes. Second one also.
X minus 1 divided by x plus 1. So
Why is -1 eliminated?
Because in the denominator, it should not be minus 1.
Okay.
okay.
Okay, so you understood this. From here, what we can say is, what about the domain for this part? Now, what are we doing is, we are respecting the conditions for all of these, right? So first we told that this has to be greater than 0, right? And then second, we are saying that this, we are still with the definition of log, right? So this is a, right? Log to the base a. So the a should not be equals to 1 and a has to be greater than 0, right? So based on this, we wrote this. Now again, for this individual thing, we will have to define what is its domain. So for this, x should belongs to what? R, but except what? Except 1 and minus 1.
1 and minus 1.
Because the moment we give this 1 and minus 1, this will become not defined. So we will have to remove that part, right?
No problem with minus 1, na? I think minus 1 is okay.
1 square.
Whether -1 or 1, you get
1 it is like
denominator.
No,
It's a
for
square
every-
function in
it's
the
a square
denominator.
function.
X square, na?
Denominator, it will go 0.
Will be
Do we
0.
need to
For 1
remove
and
minus
-1.
1 also? Because minus 1, it will become positive only.
No,
but
but
denominator will
the
become 0.
denominator,
Then x square
Denominator will
minus
be
1
0.
will become
1
0.
minus 1, because it is squaring the values.
Okay. Clear, sorry.
Sir is not audible.
This revision session, when they announced, I never got any notification.
No, it was not announced anywhere.
Calendar update.
No, it's there in the Google Calendar.
Yeah, Google Calendar is there, but
No, last class we were all asking the
requesting.
sir.
Yeah, in solve with
Requesting.
this session.
Krishna ji, are you in the WhatsApp group? We created one small WhatsApp group. Do you
No.
have? I will share.
Okay.
Sandhya, can you please share the link of the group?
Sir, you are not audible.
Okay, sorry. So now the second part here, the third part, how did we get this interval? It's just the same thing we'll do. We will understand that it's extreme conditions, what happens, and then we find its domain, right? So how do we do that? So let's do it quickly. So when you do this, you will find out that if you take this x minus 1 and x plus 1, so what happens? How will the graph look like for this function? Could anybody help me out solving this?
Yes, in the number line, when we
Yes, sir.
go for x minus 1, we have to
So
1.
you see this, what happens at infinity? It turns out to be 1, right? So let's say if this is 0 and let's say this is 1, so what happens at, let's say this is 1 and this is 0, what happens at infinity? This is turning out to be 1. And what happens again at minus side, it will be 1, and we are not sure what is happening in between, right? So let's keep that as it is. Okay, now look at this part. Now we understood that at infinity this is the thing happening, isn't it? Now what happens when x goes to minus 1? What happens when x goes to minus 1?
It will be undefined.
It will be undefined. So this is the region where we have to check. So what happens when we take the value lesser than this and greater than that? So lesser than this means 1.1. Let's take it as minus 1.1. What happens at this point? When you take this, yeah, if you give this value to this, what happens to this function? So this is going to be minus 1.1 divided by minus
Minus
0.1.
21.
So this is going to increase.
21. Yeah, positive 20.
Positive.
So this is going to be 11, right?
Oh, 11.
Yes.
Right. So this means when if this is my minus 1 and if I take a value lesser than this, so it is going to increase. That means it's going to be something like this, right? Something like this, isn't it? Now what happens when you take a larger value than that? What happens to that? So now let's check this. Okay, so now what happens when you take let's say 0 point, it's minus 1, right? So let's take this as a greater value. So greater value will be 0.9, or let's say 0.1 only, right? This is greater than that, isn't it? Or let's take it as minus 0.1. This is still greater than that, right? So what happens when you give this value? When you give this, this turns out to be minus 1.1, right? And this turns out to be what? Minus 0.1, right? So it turns out to be what? 0.9 in denominator. Am I clear? Am I clear?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
So this is going to give me some negative values. That means if I come here, it is going to give me some negative values. That means this is something happening like this, right? Now let's find out the intercept. So this is how the nature of graph looks like for this one. Okay. Now we will have to make sure that where all it is greater than 0, isn't it? That is what we were interested into. But let's find out what is happening at its intercepts. What happens when x is 0? When x is 0, what is the value we are getting?
Minus 1.
It's minus 1.
Minus 1.
So at x equals to 0, we are getting this is to be minus 1. So at x equals to 0, this is minus 1. So maybe it's falling under here. So it's crossing, it's basically crossing this, right? So if this is my thing, so it's crossing this part. Now, and what happens when x is equals to, this is minus 1, right? So what happens when, now we will have to find out what is its y or sorry, x intercept. So when do you get this? When is this 0? When x is equals to 1. When x is equals to 1, this is what you get. So when x is equals to 1, so this is not 1 there. So if I have to redraw this graph nicely, so I'll show you this. How will the graph look like? At 1, this is being 0, right? And at for what value this was being negative? For 0, it was becoming minus 1, right? And this was our minus 1, and we saw that for minus 1, this is what we were seeing, right? Like this was happening, isn't it? Because you take any least negative values lesser than 1. So if I take minus 5 minus 1 divided by minus 5 plus 1, this will still give me a positive value, isn't it? Because you see, what will this give me? Minus 6 by minus 4, right? So this will turn out to be a positive value, isn't it? So, and this is what we get. Now what about since this is minus 1, this is 1, and this graph, the other side of the graph is going to look like this. So what happens when x is equals to 1? This was tending to 1. So this graph is something like this. This will intersect and it will go like this. right? So now we will have to identify all that region where it is greater than 0. So you see, from minus infinity to 1, it is greater than 0, right?
Yes, sir.
And from 1 to infinity, it is greater than 0,
Yes.
right? So we got this. So we
Okay.
understood for what all values it was greater than 0. Now this is clear to us. Let's go to intersection part. Now we understood for which all values these functions are defined, right? Now, since we got all these conditions, now what should we do with these things? Whatever we have got, we will have to find the intersection values for all of these, right? So what we will do is, we'll first draw the x in, we'll first draw this, right? So where all it is defined. So you see it is r except 1 and minus 1, right? So 1 and minus 1. So if I have to draw this region, so it's R except 1. So where is 1? So 1 is this. This is not defined, and at this point it is not defined. But for all other values it is defined. Clear? So this is that region. Am I clear? Say something.
Yes, sir. Yeah. Yes, sir.
Okay.
Yeah, sir.
Yes,
So
sir.
this is what we get. Now let's go with the other part. Now this part we understood. Now what about this? X belongs to R except minus 1. Except, so this is this one. The second part is drawn here. All region but except minus 1. And your third condition is drawn here, right? So your third condition is something like this, right? So it says what? From minus infinity to 1, where minus 1 was not included, right? So that is something we did not include. And 1 to infinity, where 1 is not included, which is this region. So what is the common region between them, between all these three? Of course, this.
The last
right?
one.
This one, this part only, right? These are only the common regions, isn't it?
Yeah.
So what will be the domain for this function f of x? It will be minus infinity to minus 1, where minus 1 is not included, union 1 to infinity. Okay, so I'll just quickly revise to you.
Sir, okay.
Here,
Sir,
so
is
let me
it
just
possible
finish
to
this.
draw this?
So what did we do here? Okay, so how did we went about? What was our approach? So our approach was, we are respecting the domain for each and every function. First we took this log of something, right? So we have to respect the definition of log. For doing so, I'll have to make sure whatever this represent x, right? So how do we say that log of x has to be greater than 0? So basically x has whatever inside, we make sure this is greater than 0. Secondly, come to this part. This is log to the base a, right? So the a should not be equals to 1. That is the definition of log. And a has to be greater than 0, right? That is also definition of log. So we exploited the definition for this one. Now this individual thing we are exploiting here, right? So how are we doing? We are checking for what values this is greater than 0, right? So what we did was, like, we find out for which all values it is going to be 0, right? So we got to know that this function will not be defined here. And for all rest values, it will be greater than 0. But now again, you will ask, how are you saying it is greater than 0? Look at this numerator. Okay, numerator is always greater than this denominator, always, right? Because this is always 1. It's always 1 greater than this x square value, right? And this is negative of this x square, so this is again still more lesser. So this is always greater than 0, right? So all we have to make sure is this is greater than 0. I mean, this is not equals to 0. For what all values? We understood this. Now again, we are making sure that this is not equals to 1. So this is something we wrote here. Similarly, we are paying attention to this part, that this is greater than 0. So what did you do? We drew the graph for this. Now you remember in the very beginning, I told you how to draw the graph for these kind of functions, right? So what did we do? We took the limit value. What happens at the extreme ends, right? What happens at the extreme end? That is our first thing. And then what happens in between, that is something we don't know. But we find out that thing once we know where that function is not defined. Wherever the function is not defined, you take the least value on both the ends, on the negative, on the left hand side and the right hand side, and then you see how does the curve behave, right? And accordingly you plot the graph. The other things like finding the intercepts of that functions will make the things more clearer, right? So you do also find that, and then you draw the graph for this, and then you find out where all this is greater than 0. That is something we saw in the graph, we understood, right? Now, once we find all these conditions, we have exploited every conditions, right? So now we have to find the intersection region where this function is defined, right? So what did we do? We drew this in number line. So what did you do? We draw this on the number line. We showed, okay, this is all set values that X is taking. For second condition, we saw this is where this is being represented, and third, this is where this is represented. And then what did you do? We took the intersection region, and this intersection region is where this function is defined. Okay, this is what we did. I hope this is okay. Clear?
Yes, sir.
Yes, sir.
Okay, if not clear, watch
Sir?
this again. Yes.
Okay, sir. Sir, is it possible to trace the curve for f of x, sir? Or is it too complicated?
F of this one.
Yes.
Actually, we can do, but we will be very much sure that whatever is happening in the domain. But we cannot say actually how does the curve look like, right?
That's
It'll be
because of
difficult.
this
It will be
base,
difficult.
is it? Is it because of the base?
Yes, yes. Because even the base is also variable here, so we need more graphing knowledge.
Okay.
Whatever we have as if now, that will not suffice the need.
Okay.
Right?
Okay. Thank you.
But certainly we can still do it. I mean, it's just we have to put some extra effort, but that is not the whole intention here. So we can just actually omit this. We can do, but it's not required, and maybe we are not interested in finding that. So it's okay. We can leave this. All we need to know is like some basic graphings how we can do and what all modifications we can do, right? So that is something we can do. Yes. Yeah. So now let's come to the other part of our activity questions. Yes. This one. Any
Sir,
doubt?
I hope this session is being recorded because I have to leave for office.
Yes. It's being recorded, so you can leave.
Okay. Thank you.
Welcome. So now this fifth question. Any doubt? So again, if you are not telling anything, I myself will tell it here. All we have to do is, again, this is greater than 0, right? This log of whatever is given, we have to make sure that this is greater than 0, right? So how do we make sure that? So you just bring it again to your page and then you see like for which all values it will be greater than 0, right? And then you find the domain. So do you have difficulty in finding domain?
Sir, I have reached a point where ln27 is greater than 3x. Now what to do here after like?
Okay. Let's do this then. If you have doubt, let's do this. So maybe let's go to our third section. So yes. So what is the thing? So could you just tell me what was that graph? So it's log of minus of x e to the power of x minus something like this, right?
Minus 27x.
E to the power 3x.
27x.
Yes.
E to the power of 3x, and even x was there, right?
Yeah.
Is this the thing?
Yes. Sir.
Yes.
Okay. So let's do this. So how do we do this? Again, see, whenever we get a question and if it is about finding the domain, we have to respect the individual thing, right? So now come to this. Now we are finding domain, right? So let's find domain. So maybe I'll increase this. Finding domain. So what we have to make sure that this is greater than 0, that is minus x e to the power of 3x minus 27, x is greater than 0, right? Or in other words, when you take this negative to the other side, so this makes it e to the power of 3x minus 227x is lesser than 0. I just multiplied on both sides with negative, right? So this is what we get from here. So for which all values now we have to make analysis here, right? So now if I have to say this, when x is positive, now here you look at this values. Now this is e to the power of 3x, right? And this is 27x, right? So how will this look like? So x, or if you want to, this is lesser than 0.
We can take common and then cancel out x.
Yes, we can do this. So we can find out this e to the power of 3x minus 27 is lesser than 0, right? So we can do this as well. So now what else we can do from here? So we can, now when will this be lesser than 0? When, so you see this is always now when, what happens when x is equals to 1? you see that whenever you give this negative value, okay, so how do you make this analysis?
So we can solve by inequality.
Yeah, that is something we can do, because here you have x times this, so let's not get here in graph part. So we can do this, e to the power of x is lesser than 27x, right? Right, so this is something we can say for what all values of x this is lesser than x. So we can say this, now e to the power of 3x is lesser than 27, or we can write this as
ln 3 to the power 3.
so now we can take this as ln, so this
3x.
will become 3x is lesser than ln of this thing, so ln of 3
To the power 3.
so 3x lesser than 3. So for what all values, so this will be 3 square, right? So 3 ln 3, right? This is what we get. So x should be lesser than ln of 3,
So,
right? Yes,
so normally we don't cancel the x value, right? Because we will lose a value then.
right. That is right. So over here, yes. So one thing is think about this, like what if we are excluding that x value and what we are reaching, okay? So one thing is this, and then if we, let's see if we can actually ignore that values or not. Over here we found out that x has to be lesser than ln 3, right? So when you had this, let's say x over here, now what you could maximum think of is, over here it says that x has to be lesser than 3, right? Now you can think of the positive values of x, right? So when you give positive values of x greater than ln of 3, what happens, right? So ln of 3 is some decimal values. Let's say now ln of 3 is definitely lesser than 3, isn't it? So when x is 3, what happens to this value? Just check this. So when you give this 3 e to the power of, this is going to be something 9, right? Minus 27 times 3, which is certainly greater than 0, because this is e to the power of 29, which is a very big number, isn't it? This is greater than 0, so we can omit this part. Okay, am I clear?
So can we also do it without cancelling the x?
That might make it difficult. So if you see it here, e to the power of 3x minus 27x is lesser than 0. Now if you take out x common from here, right, or you can do one thing is, that will complicate things. So what we can do here
Okay.
is, maybe we
So but
can
then,
try
like, what
doing
about the other value of x?
ln of x plus 3x lesser than, still you will see that some or the other way it get cancelled, because you will see again here it will come 3 ln of 3 plus ln of x, right? When you are taking x, when you are considering x, right?
Okay, okay.
Now this term will get cancelled because it's the same term. Now
Yes,
this
sir.
3 and 3 gets cancelled, so you will find x is lesser than ln of 3. So even this way also you can find. All right, so now we
So just
understood that
one step wherein you converted this e to natural log. Can you please explain that step? How did you
e to
convert e to
okay,
natural
so
log? Means
natural log means it's log to the base e, right? Right?
okay, fine.
Now, okay, you understood, or do you want me to explain further?
No, I understood.
Okay. All right. So now, having known this, I think we can do this. Now, x is lesser than ln of 3, right? And also, yeah, that is the thing. So x has to be lesser than ln of 3. So what do we have? And it says it is from 0 to, so ln of 3 is somewhere here. But why it is from 0? So can you give some negative values and check here? If you give some negative values for this domain, hello, am I audible?
Yes, sir.
Yes.
Actually, the 0, is it because of we are taking x as common? Maybe that is the reason.
No, it can be. It will take only positive values, sir. X is greater than 0. That's why I think.
Maybe.
How did we say that?
Here, if we take x as common, x common.
Okay, yeah. When x is 0, right? So what happens? It's gone, right? So this entire thing will become 0. That's why this 0 is not included. Just substitute that values, isn't it? Or when you are taking this x common, as you are telling it, It's lesser than 0. So you basically avoid taking 0, isn't it? Hello?
Yeah.
Yes,
Right?
sir. Yes, sir.
That
Yes,
is
sir.
one thing. Yeah.
Yeah,
So you
yeah.
can think that x is equals to 0 and then you can leave that.
So always we can do like
Yeah,
do like
because
this.
yes, because when you substitute this x here, or like when you take out that common, you can always think in that sense.
I'm thinking in polynomials also we've been taught
Yes,
like that.
yes. Now 6.1 we can do. What about 6.2? Where all you have doubts?
Third question, sir. Third question.
First question, no doubt, right? It's just that
No.
you'll have to solve that. It's okay.
Yeah.
This thing you can do now. You know the graph. If you can draw the graph, you can draw that. Third
Sir, how
question.
to find the domain of this
Of
log to log of this
this one.
function?
Okay,
Uh-huh.
let's see this. Let's see this. Again, you just draw the graph for this. You will get it. Log 2, log 2, log 2. Still log is there? No. 3 only, no?
Yes,
No, sir.
only 3.
Yeah.
3. So we have to find the domain for this part. So how do we do this? So let's check this. So how can we do this? So now say this, this is equals to, since this is the case, right? So again, we have to respect the domain for each and everything. Over here, I'll have to first make sure x is greater than 0, right? Then when I come to this part, I'll have to make sure what? Log base 2. But again, I have to make sure this log base 2 to the base, this entire thing has to be greater than 0, isn't it? Right? This is my first thing. Now I have to make sure this is greater than 0. Why? Because this will become undefined, isn't it?
Yes, sir.
So how do we get this? Now, how do we get this? Then I'll have to say that x is greater than 2 to the power of 0 or x is greater than 1. Clear?
Yes, sir.
Right? So
Yes,
that is
sir.
one thing I can make sure. Now, I'll also have to make sure that this entire thing is greater than 0. So log 2 and log 2x is greater than 0. So when do you think this is greater than 0? So when log 2x is greater than 2 to the power of 0, correct? So this is nothing but when I simplify this, what do I get? Log 2x is greater than 1,
1.
right? Or I can simply say that x is greater than 2 to the power of 1, which is nothing but 2, right? So when x is greater than 2, then this function is defined. So what is the domain of this function? 2 to infinity.
Okay.
Clear? Now,
Okay.
the other way of thinking is you can think of graphically also. One is log x graphing like this. This is at 1, right? Now think of at what value this will again become 1, wherein you can find its intercept, right? So for what value? Okay, let's not take it in that way. For where all it will become undefined and where what is its intercept. So when log 1, when x is 0, this will become undefined. So you will have this asymptote condition coming in here. And log 1 is your this intercept, right? So this log 1 is 0, so this goes like this. Now we have to make sure when will this become 0, right? So for when this was becoming what? When this is at 1, so when this value, right? At this value, this will become asymptote and something goes like this. Now whatever is this value was nothing but what did we get? We get something like 2, right?
2.
So at 2, so you would see that, I think we made somewhere error, but let's see this. At this value, this will again form asymptote and the graph for, this is the graph for log 2, log 2, log 2x. Okay, this is what you get. Okay, am I clear? So this is basically 2, this is 1.
Okay, sir.
Okay, so do we have anything like that? What is the answer for this?
1, 1 and inverse.
It is 1, 1 function, definitely. The domain for this function is 0 to infinity is wrong. F as an inverse, certainly right. The straight line x equals to 8 is an asymptote, no. Straight line x equals to 2 is an asymptote, right? Isn't it?
Yes, sir.
Okay. See, at 2 it was forming this.
Right.
Right? Because substitute 2 in this. What happens when you give x equals to 2, this will become 1. Log 1 is, right? This will become 1 at 2 when x is 2. What about log 1 to the base 2? It will become 0. And log 0 to the base 2 is nothing but where it is forming this asymptote, right? Clear?
Yeah, right.
So
Yes,
now
sir.
we understood this as well. So that's okay. Now let's come to this. This is done. So we can do 6.2. Let's go to 6.3. Yes, over here. Any doubt? You can do all these questions, right? This is easy. 6.3. Let me know if you have doubt. All of you are silent.
Sir, I have doubt in
It feels like I'm
6.5.
on mute sometimes, like I'm still in that mood. Like, oh, did I go mute?
I have to leave, sir. But thanks for the session.
Yeah, you're most welcome.
And a little bit, this notification, we are not, today's session, I missed it.
I don't know. We actually told to give the announcement, but the announcement is not given. This is something I'll ask to them.
Okay.
No
And
problem.
also
Yeah.
this early morning session is very helpful, sir. Even if you make it little earlier also, it will be helpful. But it's up to you.
No, sir.
Okay, thank you.
7 is
Thank you.
fine.
Okay.
7 is fine.
7 is fine, sir.
Yes,
Okay.
7 is fine.
It's on request of you guys only. It's actually from 9 to 8, and now it's
No, 9 o'clock is too, no, sir.
I know it's because of you, Krishna ji. Like you told you have office from 10. So you're
Yes,
like,
sir,
okay,
sir.
keep from 8 to 10. Then we're like, okay, let's,
Okay, sir.
It's okay now. It's okay.
Thank you. Thank you, sir. Thank you.
No problem. So now you see this, no doubt on activity 6.3. Over here also, I'll just tell you how it is done, right? So the domain of function f of x is -3 to 1. Then the domain of this is. So what is the approach? Can anybody tell here?
Should we'll take the log x and we substitute 3 in this.
Okay, substitute this -3. What happens?
-3.
What happens then?
Ln of -3.
You see this, basically you look at this, e to the power of -1. When you substitute this here, ln of e to the power of -1, what do you get? -1.
Yes,
right?
So e power -1.
So -1, does it comes in this domain? E to the power of -1, does it come in this domain? Does it come?
No.
No.
Oh, -1.
-1 comes, no?
This comes -3 to
This is
-1.
Now let's look at this part.
But -3 doesn't come.
-3 comes. See, what I'm trying to say is we'll go in the order. Wait. When you substitute this e to the power of -1 to this ln value, what do you get output? Ln of e to the power of -1 will give you -1. So -1 does fall in this range, in this domain, whatever is given.
Yes.
Right? Now let's go with this second part, this second interval which is given. So e to the power of 3. So ln of e to the power of 3 is 3. Does 3 falls in this domain?
Yeah.
No. 3 doesn't fall in this domain.
Yeah, that's what I meant. -3.
Oh yeah. That's what I thought to take it in the order. I understood, but I wanted to bring in the order. So over here we understood this. Similarly, go with this. What is ln of 0? Ln of 0 is not defined. Sorry, you cannot give actually that thing, right? So what is ln of 1? Ln of 1 is
0.
And look at this. This is like infinity. It can go to any values, right? It can go to some very big number. It can go e to the power of, let's say, 100. That still falls under this domain, right? So when you give e to the power of 100, right? So what happens when you give e to the power of 100? So e to the power of 100 will give you what? F of 100, right? F of 100 falls under this domain? No. So I can omit this as well. What about this? This is also similar way I can omit, right? Likewise, I can do something for this. E to the power of -infinity and e to the power of 1. What happens then? E to the power of -infinity, if I substitute here, I mean, since this is not included, so that is something we can give, right? So e to the power of -3, which is not included, will give you f of minus 3, that minus 3 is not included. So this is perfectly fine. And if you give this e to the power of 1, it's essentially the same thing, right? This one. So the fourth option should be right for this.
Yes.
Right?
Yeah.
So it's just that you have to check with this, right?
Yeah, yeah. We have to
So you
substitute
will
and
see that is the answer and check that. Similarly, look at this part and you will understand this. What all you have to do is you just do some kind of, graphings and you will know. See, what you have to do is ln of e to the power of x minus 1 by e to the power of x.
it's the
Do some
same way
analysis.
we have to say e power x minus e power minus x greater than 0.
Greater than
Can
0,
we do
and then
that?
you find. Yes, yes, yes. That is the same way you will go, right? And for increasing function and decreasing function, similarly, you can check. Okay. Then what about this here? You have to take log to the base
Yeah, yeah.
3 on the
This
both
is
sides.
easy. This is easy.
Log to the base 3 on the both side, you will get it. Over here,
Even
what
this
you will
also log ln we have.
you can do that as well. You can do that as well. Of course, you will have to go that way. Ln of this thing and then solve it. Then
Yes.
further, you will have 2 to the power of 2x minus 2 to the power of x minus 12 is equal to what you
0.
say 0, right? So then 2 to the power of x, you will give it as, let's say, y, right? And then you solve this, right? Understood?
Okay.
Or you have doubt in this?
Sir, second question need to explain, sir.
This one?
Second question. Second question. E
Fourth, no
power.
doubt, right? Fourth, you can do, right?
No, sir.
Huh?
Yes, we can do.
Fourth, you can do. Second one, yes. What is the thing? Yes, tell me.
So generally, the e power x minus e power minus x means we termed it as okay, natural logarithm present. So that's why that is increasing function, isn't it? I only thought about e power x minus e power minus x, which is nothing but a sine function, like that I thought. So that's why I have doubt. Okay. Before that, the natural logarithm is present, so that's why it is
Yes,
increasing
yes,
function.
yes.
Okay.
Okay. So now let's go to 6.4. Over here, what will you do? First one, easy to do. You have doubt here?
Sir, it's easy.
Easy? Okay.
Yes, sir.
This one, how do you solve this?
In second one, I do have a doubt, little one doubt. Like x will have minus 4 and 4 both values, right?
This is simple. Like how you should do is, since this is
I have
plus,
calculated.
right?
I've got the answer, but I'm getting two answers, like minus 4 and 4.
So minus
I think
4
for
and 4.
minus 4.
Like for square root, we are getting two values, right? Positive and
Yes,
negative.
but for minus 4 log 12, the first term is not, defined, no.
Okay, got it.
So you see, when you have something like this, right? So I'll just show you here. So you have this.
Okay, got it. Like for minus 4, we are not getting any value, log value, right? That's
12,
why we are not considering.
Yes. So that is something you can always keep when you are solving this. So this is this is only the question, right?
Yes, sir.
And is equal to
equals to 1.
1.
So whenever you solve this, your first step should be my x plus 2 should be greater than 0, and over here x minus 2 should be greater than 0. This is the first step you should think. So x has to be greater than minus 2 or x has to be greater than 2. So certainly what you should think of, that x is greater than 2, the common region between them, right?
Right.
What is the common region? From minus 2 greater means this is from here. If this is minus 2 and 1 is 2 is greater, then of course this is the region, right? So you will think that from 2 to infinity, this is your the common domain, right? So this has to be the domain for this function, right? So now we found our domain. Now similarly, then you solve further and then you get the value. So how do you? This is in the form of log m plus log n. Then you can simply apply your formula, right? So what do you do that? You know that, right? So do you want me to take further? You can do it, right? Log 12, then you can take this x plus 2, and then you will have x minus 2 is equals to 1, and then 12, you can solve this. X plus 2 and x minus 2 is equals to 12, and then simplify this further and get it. Okay?
Yeah.
Yes.
Okay, so that is something you can do. Over here, the number of solutions. Similar way, something is given to you. You can simplify this, and
Yes,
then
yes,
again you can get
you
this.
can use the
This
multiple.
is doable again. Yes. So let's go to the next 6.5. So this one, this is like something you should know. It's like what happens when log, when you have like, let's say this value like log 9. What do you get? You get some decimal values, then you have to increment that value to get the number of digits. Increment the value by 1 to get the number of digits, right? That is what we do, isn't it?
So
Sir,
what
please
We have
explain
to
this
take
one. I
log of.
didn't understand.
Do we
You
have
mean
to take log of 15 power 7 square?
something like this? So 10 to the power of, it's 7 square, right? So it's 49, isn't it? And was it 10? No, right?
No, sir, it's 15.
15. It's 15 to the base 10. So to see this, you have to do some kind of understanding here, so that they are asking how many terms it has, right? So could you tell me how many terms does this, how many numbers, or what did they ask?
Digits.
Digits are there. How many digits are there, right? So how many digits are there? So could you tell me how many digits are there for, let's say if my base is 10, 10 to the base 10. So how many digits are there?
1.
1.
Here
Log
it
10
is.
to the base. How many digits are there?
1.
1.
How?
9 log 10. Oh wait, it's
No,
log base
the
10
base
9.
and they are
Base is
not
10.
equal.
So is it log base 10 10 to the power 9 or?
Okay. So no. This is base 10. It's not 10
2.
to the power of 9.
Okay, okay.
It's 10 to the power of.
Okay. So over here, let's do some simplification. Okay. So let's not get here. Maybe, so you will see here, this is 49, right? Log 15 to the base 10, right? Okay. So now understand this. How many digits? Now what happens when you have 15 to the base 15? So what do you get? You get one digit, right? So you get one digit, right? What happens when you have log to the base 15, and if it is 15 square? 15 square is nothing but 225, right? So 225 is giving me what? You have two digits, right? So what are you seeing here is, okay, so maybe we can find another thing. What is log 15 to the base, let's say 30? What do you get? How many digits do you get?
1.
Uh,
15.
You can actually use your calci and tell. So maybe, can you quickly see that? Can someone solve there?
Let make it in the base of 10.
1.25, sir.
Yeah, make it in the base 10 and still get it. So you can still do it. So what is log 30 by log 15?
15.
15. That is 1.26.
How much?
1.26.
1.26.
Mm-mm.
Something like this, right? So how many digits it has got?
1.
So what do we really mean by?
Is it one digit?
So how many digits are there in 15 to the power of 49? So the number of digits they are asking. So how big that number is, right? So how big this number is definitely depending on this, right? So if
Can
I
we
have to
say
tell you,
49 digits?
so now you see this, what do we really mean over here is, so initially I'm asking you, if this is 10 to the power of 1, how many digits it has got? 2 digits.
1.
10 to the power of 2, how many digits it has got? 100, right?
So
10 to
how
the,
come log base 15 225 is 2?
I think I don't know why somebody told me, so I wrote that. So just avoid that for time being. What is 10 to the power of 3?
Okay.
What does this gives you? How many digits it has?
4.
4. So you look at the power. When power is 1, you are getting 2 digits. When power is 2, you are getting 3 digits. When your power is 3, you are getting 4 digits. right? So how do we see it when we are giving log? Okay, right? So how do we see this? Or like, okay, so look at log 10 to the base. I'm taking to the base 10. Okay, so what is the how many? What do you get?
One digit.
1. So that means I'm increasing one value, right? I have to increment one value. So I get 1, but how many digits do I have? Plus 1. I will add plus 1 to that, then I will say there are 2 digits. Likewise, for this, when it is 10 square, 10 square, so how many, what do I get log for this? I get 2. Now I'll increment by 1 and then I'll say the number of digits are 3. So you get 3 digits,
The
right?
number of digits of what is 3?
See, basically the question is how many digits this has? 10 to the power of 1. How many digits it has?
2.
2. How many digits this has? 10
3.
square? 3. How many digits this has?
4.
4. Likewise, if I have to ask you how many digits does 10 to the power of 100 have? So what will you say?
100.
101.
So 100 plus 1, right? So it will have how many digits? Digits
101.
will be 101. So what are we doing? We are increasing by 1, right? Over here also 3 plus 1. Over here also 2 plus 1. Over here also 1 plus 1.
So we need the number of digits of the answer.
So that is what. So the question is not the log of this, but the question is 15. Sorry, yeah, it was 15, right? And then 7 to the power the whole square. So how many digits it has, right? So how do you get it? So you can say that's 15 to the power of 49, right? So now you cannot say it will be 49 plus 150. No, that is not right. I'll tell you why I'm coming to that part. Now look at this thing. What happens to this? You understand this one?
We understood, sir. So should we have to do it in a calculator and check
No,
that?
but somewhere you need calculator. I'll tell you where. But look at this part. So what do you do here is when you say this log to, sorry, what happens? How many digits does this have? Can you tell me how many digits does it have? Like 10 to the power of 1.1. Could you check with your calci? Or maybe
2
I could.
digits, sir. 12.5. So 2 digit.
2 digits, right?
Mm-mm.
Do you get 2 digits? Just check it again.
We are getting decimals.
You get some decimals, right?
Yes. So should we add
12.58.
Yeah, 12.5. It's
12.5.
almost
So again, we can say that this is like on, the number value will be something like 12. That means 2 digits. That means between 1 and 2, I always have how many? 2 digits, right? When the degree is 1 and 2. So I always have 2 digits, right? Like if I give 1.9 also, you will still have 2 digits. That means it's the integer value and that, right?
Yes.
Likewise, I can do for this 49 log 10 to the base 15. So what is the value you get? You get some values. So 49 times 1 point, maybe some 7, blah, blah, something you get. Then you increment one value. So you multiply this, then you increment by one value. That will be the total number of digits this function has. I mean, this given equation has.
That is 42.6.
42.6. How can it got decreased? It should increase, right?
Sir, in calci, log 10 divided by log 15, isn't sir?
So what do you get? Like to the base 10 you are telling.
If it like it would be ln I as log base e, right?
Log base 15, sir.
ln 10 by ln 15, right? Then we should go.
Let me check with my own calculator.
Is it 83.3? 49 into 1.7?
No, what is the value for this one? So what I mean to say is you will have to do the product of this and increment this value by 1, so you will get it.
Sir, it's coming as 42.66.
For which the value for this one?
No, this one plus 1. together, that is 42.66.
0.85. That log 10 base 15 value is 0.85.
Yes, yes.
0.85. Okay.
Yeah, total 42.67.
I'm getting 41.66. It's 58.
58. Sir,
Just a minute.
57.6284.
So 57
Log
point.
base 10, 57.6284.
So this you will get 628 plus then you will add one digit, so that will account for 58.
Yes, sir.
So that
Sir,
will be
then
for
there's
log
a log
15
base
base 10.
10 to 15.
Sorry?
Log base
This
10 to 15.
57.62 will come when we take log 15 base 10.
Base 10.
Okay.
So for
So
that
this is
only.
what
Plus
for this.
15 raised to power 49. So we take a log 10.
Okay. So here I think here the question was 10 to the power of
No,
sorry
15 to
15 to the power of 49. Yes.
49.
So we should have actually done this. So we should have gone with this. So I forgot this. This is 15 there. So this is what we should have done. So when you simplify this, this should be like 49 times log 15 to the base 10. This is what the whole essence I was explaining you, but I forgot that I gave 15, but it should be 10, right? So now what?
Yes.
When you solve this, you get some values, but then you increment by one, right? Over here, that is what I was explaining. If it is 1.1 or 1.2 or whatsoever, this is certainly 10 to the power of, it's between 10 to the power of 1 to 10 to the power of 2, this value 15, right? When this is the case, then certainly that has to be greater than 1. So you increment the value by 1. So you find this thing, you find the product, and then you increment the value by 1, you get it. Like that. Okay. So now next, this is like you have to substitute in the formula, you get that second thing. Clear?
Sir, I
And
substituted, but I couldn't get the answer.
for which?
The second question.
For this one, okay. Suppose a certain amount of money M is invested in mutual fund at an annual interest rate of 5%. Okay, so could someone tell me what is the formula? Can someone tell me?
1 plus 1 by n whole power n.
1 plus 1 by 1 plus 1 by n.
1 by
The
r.
whole of
R by N?
R by n.
No, not that.
Is this right?
No, 1 plus R by N.
1 plus
R by N whole.
Should be 100, no?
Yes, whole power. No, N I think. It's N, not R by N. I think. It's N.
Okay, so when you say this R by 100, so it will comes out to be, okay, so fine, you can keep that as an R. So now
E by N, I guess. Yeah, and
So to the power, it will be only n. I
N,
think.
only N.
power in power only n.
n is your 4n or whatever, like how
And
many quarters,
into
right?
P also. P, principal
Amount. So this gives you your compound interest, right?
Yes.
So what is the question here? In the question, it's told, suppose a certain amount M, so P is M here, is invested in mutual fund at the rate of 5% per annum. How long does it take for? How long does it take to triple the initial investment, assuming the interest is compounded thrice a year, right? So thrice a year, 3 times a year. So this is M. 1 plus R is what? 5%, right? For how many years? 5% means this is going to be 5 by 100. What is N? N is 3 years, right?
Yes.
So, and it is compounded. And see, whenever we write this, so this should be something like, no, should we give it as 3 or R by 3? Sorry, 3, but in a year it is
But
3.
they are saying compounded thrice a year. That means every 4 months, I guess.
Every 4 months, right? So we
Yes,
should write this in
quarterly.
form of quarterly means?
Quarterly means it should be 4, I guess. 4 into.
So it is quarterly, right? So this has to be 4.
4.
I don't know. I forgot this formula. So this is going to be 1 plus, when you simplify this, let's see whether what it is the thing if we get the
So why
answer.
does
So
it?
this is going to be
There
1.
is. They didn't
Mhm.
say 3 years. It's thrice a year. So why did we do 3?
Yes, even that.
Thrice a year, no, per year. So I think it should be, since this is n means this is a year, right? And thrice a year means 3 times a year. So a year
Should
is
be
of
4.
12 months.
Quarterly,
12
Actually,
months, so
it
8
should
times
be
4.
one annually.
quarterly is 4.
Quarterly is 4, but annually they're
We
saying
should
the
calculate
interest
for
is
quarter
annually.
only. We should calculate for quarter only because it's calculating thrice in a year. Every quarter it's calculating.
That is compounded, but the percent is calculated for annual rate. Annual rate. At an annual rate, 5%.
Yes. So when you say this, principal 1 plus r by 100 to the power of n, where n is what? A year, right?
N is number of years.
Okay. Maybe I can just look into the formula, compound interest.
Maybe it is saying that thrice a year, then it would be 1/4, right?
Yeah, that's what. So it should be like 1/4. Yes, that is right. I think that is something we should give 1/4 because thrice a year, right? So yes, it should be 1/4 or something. Yes.
Then inside the n will be again 1/4.
Yes, sir.
No, this n won't be this. Why? Because you see here this was y, right? Sorry, t. T is per year, right? T is per year, isn't it?
Yes. And the n inside will be the number of times, like the thrice
The
a
number
year.
of
That is
times.
why.
So this is what? So if this is like this, so this is 1/4, and over here it will be thrice. Okay.
Okay.
Okay. So now I think we have to look into this formula. I'm just, just guessing it here. This is something I'm not very confident about. So you can actually look into this formula part. So now we can actually simplify this and see. Then this is going to be 1 by. So this is going to be 20. So this is 20 times 3, which makes it 60, 1/4. So how are they expecting answers? Is triple the initial investment, assuming the interest is compounded thrice a year. So they are saying this is triple the initial investment. Initial investment is 3M, right? So initial investment is
Actually, I have
3M.
just solved it right now, and formula would be 1 plus r by 400. And
400.
yeah. Because
Okay.
we are
Also, the
calculating
formula
price.
is not only
And
n.
in power, it would be 4t. So we are calculating time there.
Time also, yes.
Oh,
That
4 into
4t. Yeah.
4t.
4t.
Thank you. So we can just note this. So yes, please go ahead. So it is going to be P times 1 plus R by
400.
R by n.
R by n.
Yeah.
R by n.
N 100, right.
N into t.
N into t, right. And would be 4 because we are calculating thrice. N is 4.
Would be 4.
Time interest
N is
applied.
the number of compounding
Compounding
per
period.
year. Yeah.
Number of compounding period.
And t is the time in years.
Okay.
Yeah.
Time in years. Now we can solve this. So they are saying this compound interest is thrice the. So basically here M was given as P was given as M plus 1 and R is given as 5 by, and this N is number of compounding periods. So this is going to be 400, right?
Yeah.
And this is going to be 4 times T. So T is 1 year, right? So this is T is 1, isn't it? So this value is actually equals to thrice the M. This is what they are saying. 3 times the initial investment, isn't it? So this gets cancelled. So now all we have to do is
The T
just
will not be cancelled because we have to find the time.
T is not getting
Yeah.
cancelled.
T would be there, right? 40.
Okay, so T in years they are telling, no? So this will still there, right? Yeah,
Yeah.
right. I'm sorry. So this is going to be 4T. Time in year. Yeah, for what value it is
Now
going
we
to be
take
that. So
log.
yes, so we can say this as T. So now you can cancel this out and then you can get this value. So this turns out to be 1 by something. So you can actually find this value. So 1 by 80. Yes. So 1 plus 1 by 80. So maybe we can keep this. This is going to be 4T, which is equals to 3. Now
We'll
you can
take
take this.
log of this.
Yeah, so you can take log of this 4T. So this is going to be, you can actually simplify this and it is going to be 81 by 80, right? So when you simplify this, so you can tell this, not ln, but log of to the base 81 by 83. So you can solve this further. So log of 81 by 80. So to the base 3 by 4, and you can actually see what is this value giving you. You can take this nearby value, whatever approximate value you get, that should be the value. I hope like all we had to know was this formula. Once you know this formula, then the rest log thing you can do, right? Is that okay? Clear?
So log base 81 upon 80.
Yes, sir. What I couldn't understand the base part log.
We can write it in decimal, then we can get value from there.
Okay, so now 81 by, how did you get this? So you just have to simplify this. Just take this as 1 and take the LCM. So this will become 80. So 81 by 80 is what you get.
It's okay, sir. 81 by 80, but base 81 by 80, how?
How to simplify? So if you want further that is to be done is you can actually change the base also if you want. So now you can take this log 3 by log 81.
81
Now
by
I'm taking
80.
in the so 81 by 80. Now it is in the base 10 and this
Yeah.
into 4 will be here. Now you can simplify this. Right? Now you can simplify. So this is something we can do and get. All right?
Yes, sir.
Yeah. So this is okay. We can do this. Come to 6.6. Yes. Over here, how do you go? Do you have doubt anywhere here?
Sir, the second question.
Okay. So you see this, all you have to do is some kind of simplification here. You can express this 8 in terms of 2 to the power of 3, right? You can use this formula 2 to the power of 3, then you can bring this 1 by 3 log 2
Sir,
to
I
the base.
did this, but I just couldn't solve
Okay, so just
after
tell me
that.
this. Okay, just tell me this. We can just solve it here. So this is log 8, right?
X cube minus 1.
X cube minus 1 is equal to log
2x minus 1.
x minus 1, and they are asking how many solutions it has, right? So now I
Right.
can write, we can write this in the form log 2 to the power of 3 x cube minus 1, right?
X minus 1 is factor.
Yeah, actually that is right. So let's do this first. So this is going to be 1 by 3 log 2 x cube minus 1 is equals to log 2 x minus 1, right? This is something we can do,
Yes, sir.
Yes, sir.
right? Okay, so now if this is the case, then we can also do this log 3 sorry log 2 log 2 x cube minus 1. So keep this as it is. So this can be written as log 2, maybe I can
X
send this 3 to the other side,
power
right?
3.
So I can do this x minus 1. Now what? Now we can also do this
X minus
log 2 x minus 1 the whole cube, right? And since these are both to the base 3, so I can say that when these two are equal, then only they will be equal, isn't it? Because anyways they are to the base, same base, right? So when this will happen, then we can say that, right? Can we say this?
Yes,
Yes,
sir.
yes. Okay, sir.
Now
I
you can
understand.
solve it. Yeah, further you can get that. Okay, similarly
And
we
sir,
can
for
do this.
the first question. After solving, we get ln is equals to 5. Ln x equals to 10. 0 or 5. So the options are here is only 5. So that's why ln x equals to 0 will also be an answer, right?
X equals to 0, but when you give 0, it will become not defined.
No, not x equals to 0. Ln x equals to 0.
Ln x equals to 0. Ln x equals to 0. When will that be 0? When x is 1, right?
Yes.
So you have to find out. Okay, so when x is 1, then this will be equal. Correct. That is also fine.
Okay,
Ln
sir.
1 is what? 0, 0. So this will become 0. Yes, that is also true. Yes. Only one root is given.
Okay, sir.
So now let's go to the next one. Over here. Here you just have to find the values and check, right? Just substitute, just get the values, the actual value for that, and then check with these options. That's all. Okay. And the second one is looks complicated.
Yes,
Is it?
sir. Please explain.
Okay. All right. So if you were to ask me, I would say like just draw the graph for this. So how will you do this? You have been given log log x minus greatest integer function, right? So you know that greatest integer function can take the value. You know the graph for greatest integer function, right? How is the graph for greatest integer function? This includes, but the other value does not get included, right? So and this is what you right? Greatest
Yes, sir.
integer value is all set of x values.
Less than or equal to.
Yes, less than or equal to this. Now understand this. How will the graph look like? So when you see this, when x is an integer value, this function will become not defined, right? When x is an integer value, this function, I'll mute everyone.
Sir, you are not audible.
I'm sorry. Okay. So 0, 1, 2, 3. See, at all integer value, this function will not be defined. Because let's say if you give 1. So from here, this will be 1 and this will also become 1. So 1 minus 1 is 0. So it will not be defined at all integer values, right?
Yes, sir.
Right? If I give minus 1, so what happens when this is minus 1? And if I give for this one, so this will turn out to be minus of minus 1, which is nothing but plus 1. So this will again become 0 for that region, right? So even for minus 1, minus 2, minus 3, for all these values, this will become not defined, or it will be you will see there is an asymptote for all these integer values, right? But what happens in this between these values? Now you see this. What happens when you take the values between 1 and 2? What happens? Let's say you take the value 1.1, right? So 1.1 minus what is greatest integer value of 1.1?
1.
1.
1.
One.
So this will be what? You will have 0.1. So 0.1 is some negative value of log, but certainly it is lesser than this. So it will go like this. Till 3 it will go like this. Clear? Over here, this also it will go like this. You understood how this graph is going?
Yes, sir.
So I should have drawn here actually 1.1, right? So when it is 1.1, you get some values, right? You get 0.1. So what is log of 0.1? Some values, but it is negative value. It will be somewhere here, somewhere here, somewhere here. But the moment you approaches 2, this will approach, you know, I mean, when you are coming from the negative side, it approaches there.
Hello.
Yeah,
Sir, you're not
sorry,
audible.
sorry. Actually, I'm in the home and there is some kind of disturbance, so I muted this time. So it's okay. So now let's see this. So now we understood with the graph, right? So when you go with 1 to 2, you see this graph, it goes like this, right?
Yes.
Right? Similarly, now this was 1.1, what I gave an example, right? So when likewise, when you take 1.9, what happens? 1.9. So 1.9 means this is 1 minus 1.9 means this is, sorry, 1.9. So this will become 0.9. That means the value is increasing. So as this value is increasing, the log value will also increase, right? So it will go some values like this. So that's why this curve turns out to be like this, right? Likewise over here, this is going to be this way, this way, this way, this way, and so many. So there are so many, there are infinite number of asymptotes, vertical asymptotes. Clear?
Yes.
I hope I'm clear on this.
Yes, sir.
Now having known this, let's go to this. Now the set of D is infinite. Is this right?
Yeah.
Yes, it is right. So this is right. The cardinality of the set R minus D is also infinite. If this is infinite, then R minus D is again infinite.
Correct.
Both are correct, right? The graph of f of x has infinite number of vertical asymptote. Is this correct?
Yeah.
Yes, sir.
F is invertible functions on the domain. D, no. It's
So
not
is there
invertible.
a difference between invertible function and inverse function, or they both mean
Both
the
are same.
same?
Both are same. Both are
Okay.
same. Yeah. The range of this function is what? R? No.
Hmm.
It is what? 0
It
to
is
minus infinity. Sorry, minus infinity to 0. Right? Look at this graph. Look at this graph. What is the range?
Minus infinity to 0.
Right? So that is the thing. Let's check the answer.
So can you explain the last point again? Minus infinity to 0, how the range will be?
So now you see the set of y values. What are the set of y values this function is taking? What is the least value this function can take? What is the least value this function? Minus infinity.
Yeah.
What is the highest value this function tends to take? 0.
How can you say highest value 0? Can't it be infinity?
How? Look at the graph, no? What is the highest y
Okay.
value it is taking?
Okay.
Right? Clear?
At reach the x
Seems
is equal
clear?
to 2, it will be.
Sorry?
No, sir. I understand.
Understood now? Okay.
Yes, sir.
So now this part is clear to us. All we had to do was just draw that graph. So you understood, right? So something, if you have it in your hand, like, okay, these are some basic graphs we have to do, then you can always manipulate and do the basic graphings. See, whenever you do any kind of analysis, you do some kind of visualization. So do that. If you do it, you will get the answers. Similarly for this question, third question, how do you do? It's simple again, right? Simple. All you have to do is come to this part. If you get this, then you can come to this. All you have to do is just come to this part. Right?
Okay, sir.
You have to arrive at this and then you make the substitution to get these two values.
Yes,
When we
sir.
finally substitute the value of, then
You
we
will
get.
get this. No, no, this is okay, but you will have to arrive at this one. How do you do that? You do some calculations here. So how do you do that? So you take that log 2 to the base x plus log 2 to the power of 3. So it will become 3 log y to the base 2. Now change the base, right?
Okay, sir.
And then
Okay,
simplify
sir.
that and get that. You will get it. Okay.
Okay, sir. Okay.
So you will arrive at this one, this expression you will get. Once you get this expression, all you have to do is just check with these options, this substitute and check these values, you will get it. Okay.
Okay.
So
Can,
this
can
is
you please
all.
explain graph once again with that log x minus greatest? Yeah. I just
Greatest
stopped.
integer function.
Yeah,
This
yeah.
one.
This one, yeah.
Okay. So what I was telling here is, look at this graph. This is our function, right? So what happens at the integer value? Look at the integer values. What happens at the integer values? What happens when x is 1? 1 minus 1?
0, 0.
that will become infinite. So at 1 it will become infinity. What happens at 2? Again infinity. What happens at 3? Infinity. Again at 4?
Yeah.
Infinity.
Yeah,
What
yeah.
about at -1? Again infinity. How? -1 minus of greatest integer function of -1 is what? -1 again. So minus of minus will make it what? +1.
Okay.
So you will have again this 0 coming
Yeah,
in.
yeah, yeah.
Similarly, this. Now look at the values between these. So we will take 1 and 2. For example, let's take 1 and 2, right? So now what you will do? Log of, let's say first least value, let's say 1.1. Okay. So when x is 1.1, what is greatest integer value of 1.1?
1.
1. So this will give you what? Log 0.1. So what is log 0.1? I can write this as 1 by 10. So maybe if I have to do this expansion, so this I can do it at 10 to the power of -1, right? So I can do this as -1. This is
Right.
what you get. So you get when x is 1.1, so 1.1 is here. So you get some -1 value, which is somewhere here. What happens when x is 1.9? Not 2, but 1.9. Because at 2 it will become infinity, right? So what
Okay.
happens at 1.9? So this will become 1.9 minus 1. So again, you got this y1, right? Because greatest integer value of 1.9 is 1 only, right? So this will give you what? Log of 0.9. What is
So we
log of
will
0?
never get positive y values for this function, right?
Yes, you will never get positive y,
Okay, okay, okay. Okay, thank you.
right?
And
So
yeah,
this
got
is,
it.
now you will go there.
Yeah.
So this is all for today's session. We are done with activity questions, and this is all. I think now you can do the questions. Now
Yes,
see
sir.
what you can do from your end. What you can do from your end. That is something I'll tell you. First of all, learn the graphings of all the polynomials. All the polynomials in the sense, uh, linear, quadratic, then polynomials, logarithms, exponential. Know the basic graphs. Okay, keep practicing. Do that. If you can do that, is well and good. And there are some exceptional graphs where you have this x minus 5 divided by x minus 2. How do you draw the graph? So I told you in the very beginning how to draw the graph for them, right? So that is something we can do again, right? So these are two things. So these are the things you should do. So once you can do the graphings of this basic thing, you are good enough to do any kind of graphs now, right? So now you can, if that is your convince. So now let's say if you have this graphs like log of x, then greatest integer function, right? So you can do now analysis like how will this graph look like. So you can build on those things on your basic knowledges, right? So do learn this, and I have done everywhere, wherever you will see my session, I have done some kind of graphics, right? So you can see somewhere in polynomial, I have done graphics. For exponential and logarithmic also, we have done a lot. So learn this graphing part. Why I'm giving emphasis to this is because you'll be able to visualize this function. Once you are able to visualize, you will get it. For example, what you saw with that greatest integer function, f of x is equals to, log of x minus greatest integer function, like that function. Do you think it was easy for you to do it mathematically? No, it would have been really difficult. First of all, the math behind that, if you have to explain it, becomes very difficult to explain. But once it is drawn on the graph, then you can make all sort of conclusions, right? So do practice your graphs as much as possible. This is all you can do for logarithm. And the rest is like you have to obey and whenever you do the graph, so just pay attention to its, you respect the domain of the things. You respect the domain for those functions. Okay. And that's how you get it. So this is all for this. Okay. All you have to do is now just give a practice to all these questions. Once you do, you will be able to do it. All right.
Yes,
Yes,
sir.
sir.
Okay. So now I think we are
Any
done.
book can you
Me and
suggest for logarithms?
Any books? What I
Yes.
can suggest is, first of all, be thorough with what we have done. Okay. And
Yeah.
if you feel there is a need, then what you can do is, what you can do, just go with some
Especially
questions.
graphing of logarithms.
Graphings of logarithm you should actually practice by yourself. You should practice using some online tool. Okay, take some
We
values of log functions and then keep doing the graph
have
for
to
that.
do all by ourselves. Then we'll get it.
Yeah, so I don't think so any book will actually give you
No, what I meant is more practice means more number of problems if we do, even then we can do better. That's what I meant.
Right, right. That is what. If you are able to draw the graphs for things, the things goes very easy.
No,
If you see your previous quizzes, like what we have asked, uh, it's more on this graphings only. We'll give you a graph and then we used to ask, okay, what is the domain and what is the range? And
no,
this
drawing graphs for quadratic and polynomial are easy. Logarithms are little. Logarithms, exponential is also easy, but logarithms are little.
logarithms, okay, but again, like what I have done, just go with the flow the way I have done. Okay. Like I have taken in all my sessions, you can see I have done graphing. So at least just see that part. It's not very lengthy. You would see it's only 15 to half an hour. Just know that how I'm doing and practice that thing in online to, let's say, Desmos and GeoGebra, like whatever I'm doing.
Normally, actually, log x will always go to the right side. Yes, from the asymptote will be towards the y-axis, and it will be vertical asymptote. So that's how we have to keep on adding x minus 2 and x square like that. So what I am thinking.
Yes, yes.
So whenever we want the
I will tell you, whenever you want to draw the graph for log, right, you see where it becomes 0. Wherever it becomes 0, that is the place it is going to be.
The expression inside the log should be equated to 0. Then we can find the values of x. That's what.
You get the value of x, and that is the point where it becomes an asymptote, where you will find the asymptote. Am I clear on this? See, what you do is you equate to 0 and you find the values, and then you will say that, okay, at this value, there will be an asymptote.
When we equate the 0, yeah, okay. That's when we get asymptote. And
log of whatever is given inside, when you equate to 0, that is the whatever given inside equate to 0, then you will get the asymptote. When you do log of those value equals to 0, that means you are finding the x-intercept.
Okay, asymptote we will be getting with the inside expression, and the whole expression gives the
x-intercept. X-intercept.
So
okay, yeah.
It won't give
Practice,
f of x. The whole expression should give f of x, no?
The whole expression should give you f of x. So when you equate that f of x to 0, essentially you are saying that my output is 0.
Yes.
So you are talking about your x-intercept. So that is the thing. Okay, so what you can do is just practice. Just give some time for this graphings. Believe me, you will find its importance as you are going further to the courses, wherein you will have the bigger maths terms coming in. No? Then you will be able to say, oh, this is what graphically it looked like. And then you will be able to appreciate it better.
And I wanted to ask, where will we use limits exactly in the real world, real time?
Complexity of algorithms, you will find that there's immense use in that.
I mean, where will we use this complexity?
ML, machine learning.
When the data grows, how the time grows with that, you can find one of the application of limits in that also.
Normally, in growth of rate of change.
Like when n grows to infinity, the data if grows to infinity, so then how does
yeah. So when the data is infinite, so at that time limit helps us.
Yes. There are so many other places where you will find its application, so you will appreciate it as you're going further. Even here in the graphings, when we were doing that graphs, you see, what we were actually thinking, when this x goes to infinity, what happens? What was real idea behind that? And how did we solve it? We were applying the limit concept.
Yes,
right? The moment you say when x goes to something, that is something means that is basically limit, no?
Yes. And when we take when we take n tends to infinity, like how will it be minimum or maximum? Or n tends to 0, will it be minimum or maximum?
That depends upon the function.
I mean, I don't know. I mean, what we say normally, if we go.
Okay, you tell me if you have a function 1 by x, when you approach to 0 from the left hand side, what happens? You get the minimum value or the maximum value?
Can you repeat the question?
You have a function called 1 by x.
Yes.
I hope you remember the graph for this.
Yes, I know. The graph is on the either side.
So now you see, when you approach from left hand side to 0, what happens? Your value increases, decreases, what happens?
0 is undefined. And
Approaching the 0. You're approaching 0 from left hand side. What happens?
It takes an asymptote. No?
Asymptote, yes, perfectly right. But which direction? Positive direction or negative direction?
Goes to positive, no?
No. When you're coming from negative side,
it goes to minus infinity.
Minus infinity. So it's minus infinity means very large negative value, right?
So it is minimum.
But again, infinity, you cannot say it is the least value or something because you don't know what infinity value is, right? So
It's a very large maximum value.
Yes, just consider that is a minimum value, but it is very, very large value, and that is something we do not actually consider at all, right? But all I want to give you a picture of it, like the minimum value can be anywhere. It is not at just infinity. As you are tending to 0 also, you will find the very large value, right? That is what I meant to say.
That is minus infinity is always lesser. No?
Minus infinity, yeah. So that is what, when you are coming from the left hand side. But when you come from right hand side, you will get very large value and on the positive
That will be
direction.
infinity. Infinity is always maximum. It tends to maximum.
So yes, so what is the essence is, like, why did we bring this topic was like, it's not necessary that only at infinity you will get, when x tends to infinity you get the larger value. Even in between you might have a larger values, right? Right?
I did not understand.
Okay, so your question.
But just you take x as positive values like 1 by 2, 1 by 3, 1 by 4, write down the values, and 1 by minus 2, 1 by minus 3, 1 by minus 4, write down the values, then you are able to understand very well.
1 by minus 4. Yes. But still it's a minus value only, no?
1 by minus 2, 1 by minus 3,
1 by minus 4
minus
will be maximum value.
Observe how it's going.
Yeah.
When you are increasing the denominator in negatives and in positive, how the trend is going on, the value.
If you put bigger value, then it becomes maximum. Yeah.
Okay.
Yeah, I got it. Thank you.
It's okay. Yeah, all right. So do practice as much as you can, and I think for your quiz too, you have enough time for practicing all this, right? So trust me, even if you don't get, even if you're not touching all horizons of questions in logarithm, but you might be tested in your logarithm, in your n terms. So do pay attention for this week, at least for logarithm. Exponential is like just the, it's just given to you, like, okay, this is something. But to solve the exponential questions, you need logarithm again, right? So you will always see there is an intermixing of the questions from week 5 and 6. Okay, so this you should take it together. All right. So see, you have
पेज
time.
2 के पहले रिवीजन सेशन होगा ना?
होना चाहिए, देखते हैं.
Sir, I have a query. Sir, this is not related to the coursework. Actually, I am unable to access the forum for Maths 1. I have been writing to the support team, but they were unable to solve the problem, and I haven't heard back from them for the last 5 days.
Could you send them reminder again? I think they will respond.
I did
Suppose
tomorrow already, but I
you
don't know
didn't get
what
any
to
response.
do.
Okay,
From
maybe
the
I might.
beginning of the term, I haven't been able to access the forum.
Oh, I see. So Shreya, you can actually give me your student ID. You can post. You can direct message me here. I'll copy that and I can just highlight that to them once.
Okay, sir.
Yeah. So yes, this is all for today. We thought we'll finish it by 1.5 hours, but did not happen.
I have one question, but not related to the subject. This quiz, there is no pass-fail criteria in quiz, right? As I am aware.
No.
Okay, this is only for term exam, 40%. For quizzes, there is no need like that. Okay, thank you.
Yeah. All right. So yes, text me or mail ID. Yes, I got it. All right. So thank you, everyone.
Thank you,
Have
sir.
a good day. Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Thank you for spending your early morning hours with us.
Thank you.
More than 3 hours.
Yeah, that too early in the morning. Thank you so much, Vicky. Thank you.
Excuse me, sir.
Left. He has
Hello?
left.
Got disconnected, I think.